In this new AI era, data engineers will be in demand if and only if they know this skill. And I'm talking about RAG, Retrieval Augmented Generation. This is the only skill in this new AI era which is aligned with the databases and data modeling. And nowadays, companies want data engineers to build these RAG solutions just like other data warehouses. So it's the best time for you to shine. That is why I have created this 3 hours long RAG masterclass so that you can become a pro RAG developer from scratch. And this course will start with the fundamentals, and progressively you will be able to write code to build the real world RAG solutions. Along with this, we will also integrate OpenAI hosted models into our RAG applications and also load LLMs locally using Docker Model Runner. The best part, this course is full of cool visuals so that you can easily understand those complex topics, plus all the notes and code examples are provided with this particular YouTube video. In short, this is the only video you need to master RAG as a data engineer this year and make yourself AI proof and just crack your dream job offer this year. So hit the subscribe button right now so that you will be able to get all the important masterclasses on this channel. And let's get started with this amazing masterclass on RAG. So what's up my data fam? How is everyone? You should be super excited today because today we're gonna talk about RAG, which is the most important area of AI for data engineers. If you ask me, hey Ansh Lamba, we have AI everywhere. Okay, everyone is talking about AI. For data engineers, what is the most important thing in AI to learn? The answer is RAG. RAG. And that is why just go to LinkedIn, just go to any job portal, okay, and just search for data engineering roles, or let's say AI data engineering roles, and you will see RAG everywhere. And do you know what? RAG is for data engineers. Let me just validate the statement. RAG is basically a kind of database that is for AI workflows. Who is the master of databases and data stores, whatever? Data engineers, because you need to apply data modeling, you need to just store your data efficiently, you need to manage the data stores. That is why AI engineers who are coming from the software engineering background are struggling a lot to manage RAGs because this is not their area. RAG is the area where data professionals shine. But who is talking about RAG in the world of data engineering? Ansh Lamba. So just trust this guy and just master this RAG as soon as possible, because this will become very competent in the near future. Why? Because see, now you think that if you are not learning RAG and you are assuming that other person is not learning RAG, that is not true, because other person is already learning RAG. Okay, so you need to master RAG, and that is why I have created this free masterclass for you all, so that you do not need to spend any money, because I know what's going on in the market right now. Just refer to this end-to-end masterclass, which is for RAG for data engineers, even for, I would say, for any data professional. Okay, I would say for anyone, but that is my perspective, that if you are a data professional, you can understand RAG better than anyone else. This is your flex area. You should flex in RAG. Okay, so in this particular masterclass, let me talk about the prerequisite. The good thing is there are no prerequisites required to continue with this video. You do not even need to have any ML knowledge, any LLM knowledge, any GenAI knowledge. Now, some of you will say, Ansh Lamba, we have watched your generative AI full course. We have watched your LLM full course. So will it be beneficial? Or if we have not watched those courses, should we watch it? See, in order to continue with this video, even if you have not watched those courses, it's fine. You can continue with this video, but just bookmark those courses, because those are the backbone of AI. So you should complete and watch those courses as well. But just for this video, you do not need anything. Make sense? Okay. So without delaying, let me quickly discuss what we're going to talk about in today's masterclass, because I know your time is very precious and you will be saying, Ansh Lamba, just tell us what we're going to master today. And let me be very honest. This video is already recorded, so I'm now just recording this intro part because I know the quality of the video is super high. Cool graphics, cool animations, plus live demonstration using cool infographics, and it is going to be a big one. And the best thing, I have already mentioned that all the notes, code examples, snippets. What did you say? Code examples. That means we are going to code as well in this video. Yes, you are going to code as well in this particular masterclass. I will literally show you how to build a RAG, not just theoretically, but practically as well. It is going to be a masterclass, like masterpiece. Okay, so let's quickly discuss what we're gonna discuss in this particular video. We are going to discuss all of these topics, and I would say much more than these topics. So we will be starting with some basic understanding about embeddings and LLMs, and then we will be just starting with our APIs, and then we need to cover some topics such as called why RAG, because you need to understand why do we need to use RAG. We are talking about RAG. So you can see that we are covering all the fundamentals as well. It's not like jumping directly into the implementation. No, you will build strong fundamentals first. Then we're going to talk about vector database. Then we're going to talk about open AI. Then we're going to talk about loaders, chunking, splitters, RAG storage. Basically, these are the techniques or basically steps we follow in order to build the RAG application. So you will be learning everything step by step. Then we're going to talk about different kinds of RAG: in-memory RAG, persistent RAG, reusable RAG, custom metadata RAG, multi-document RAG. So everything is covered in this video. If you had a thought in the past that you will master RAG one day, this is the day. This is the day. I'm telling you, bro. Just treat this video as a binge watch and you're gonna enjoy it. Let me be very honest with you. You're gonna enjoy it. And the cool code snippets are like the game-changing thing, because you will be building RAG on your own without any kind of knowledge. So that is amazing thing. Okay. Then we gonna talk about so much of useful things as well in RAG. Okay. Are you excited? Are you excited? I don't know, man, because I'm putting so much of effort just for you so that you can learn AI data engineering almost for free. I am trying my best to make it affordable to every single one. And in return, what I just ask, a small comment, a like, and just hitting the subscribe button. That's it. And that's all you need to do in return. That's it. Why are you not doing that? Just hit the subscribe button, you all, because I know my lovely data fam has already done that, but you now can become the part of my lovely data fam as well. Just hit the subscribe button, just drop a lovely comment, and hit like button as well, obviously. And you can just share this video with your friends as well, because you should help others as well. I still remember, like I just talked about, just drop a lovely comment. So there was a guy who wrote lovely comment, and he mentioned, like, because you said you drop a lovely comment, so he just wrote lovely comment. I love these people. Okay, so now let's actually get started with the video. But you know what, before that, I want to celebrate some of the happy positive moments before starting with this video. So these are basically the hardworking people. Basically, these are my lovely data family members who have recently cracked the job offers, and thank you so much for notifying me. And so sorry if I just missed your message or comment, but you know what, I'm literally happy from the bottom of my heart. And congratulations to all of you. You will say just two, bro, hold on. So we have more. So congratulations to all of you. 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 And we have more. Yeah, congratulations to all of you. So these people actually followed the content on this YouTube channel and dedicatedly, I would say, practiced along the videos. And see, this is the result of their practice. This is the result of their hard work. They didn't question anything. They didn't doubt. They simply followed, and that's it. And that's you need to do in order to obviously crack any job offer. Make sense? So now I also want to see your comment here, because I know you will also crack your dream of a dream job very soon. I am with you. You will find all the videos, all the resources, everything on this channel. So just hit the bell icon as well, so that you will be notified on every video upload, so that you do not miss any important concept. Because see, I will be uploading so much of content so that you can become a competitive developer, but it's your responsibility to consume that content as well, right? So I know you will do that. I know. So let's get started with the video. And there we have some more. Okay, congratulations to all of these as well. So now these are my handles. If you want to follow me, if you want to just let's say connect with me, these are my handles, and that's it, nothing special. So let's get started with this amazing masterclass, and let's try to master RAG in a step-by-step approach. Let's see. So now it's time to discuss RAG masterclass. Okay. So RAG is a very wide term, to be honest. Okay. Very wide term. It's equivalent to, like, I'm talking about term. RAG term is like in terms of you can say use cases. So RAG in today's era, RAG is equivalent to a database. Literally, yes. RAG is equivalent to a database in today's era. So if I ask you a question, let's talk about database. You'll be like, wait, what kind of database? What is the use case that you want to perform with that database? What is the end goal to create the database? And so many other questions, right? Similarly with RAG as well. RAG earlier was just a term to talk about databases in AI, but not now. RAG is much more than that, because we perform data modeling with RAG, we perform so many other things that we're going to discuss today. Okay. So just for your kind information, do not feel like RAG is just a term that we need to learn in just 10 to 15 minutes and that's it. This is just one of the terms that we can learn in AI. RAG is the backbone of AI data engineering. Okay, let me just write it for you. RAG is the backbone of AI data engineering. Now just tell me one thing. You are a data engineer, okay? Or you want to become a data engineer or whatever. If you want to do anything in today's era, if you want to do anything, you need to know RAG. Okay? Because the heart of data engineers is data warehouse, database, data lakehouse, data marts, and all those things, right? Data modeling. RAG is the new player that has joined this group. Make sense? So earlier we used to talk about, let's say, databases. We used to talk about databases. Okay. Then we used to talk about, let's say, SQL databases. Let's say MySQL, Postgre, or so many other things, right? So many other things. Let's say data warehouse. So we used to talk about these things so far. This was the traditional stack. And don't worry, I will just provide all of these notes. Okay, don't worry at all. So we used to talk about all of these things: databases, MySQL database, data warehouse, data lakehouse that we just got it from Databricks, and then data lake as well. So we used to talk about all of these things in the world of data engineering. This was, I will say, these were the topics that were really popular till so currently it's like almost 2026. So these topics were really, really popular till 2024, or I would say 2025. Okay, till 2025. So this was the era till, you can say, 2024 to 2025. Okay, I'm not saying like this is over, but now this is transitioned to a different one where we have all of these things. Okay, but along with it, we have something called as RAG as well. So this is the new era of data engineering. Make sense? Make sense? And this will be like, let's say 2025, because 2025 is almost over. And why I'm writing 2025? Because in 2025, we saw so many use cases of RAG. So yes, 2025 till future. Okay. I can say that it can replace so many traditional database approaches, replace so many, but not all. In some areas, it will integrate with those services. In some areas, it will totally replace those services, or it will just replace the approach, how we used to perform the data modeling. Okay. Because see, you are evident of the evolution of data. Earlier, we just used to work with structured data. Then we started working with semi-structured data. Then we started working with files, and then we started working with unstructured data. So now we are into the era where we want to work with the embeddings. Now, what are embeddings? Don't worry at all. I know it's a new word, but we will cover that as well. So this is the era where we want to talk about embeddings, meanings of the context that we are passing, user history, user chat messages. So we want to perform data modeling using that as well. So this is the new era. Make sense? So this is a transition that you would see in the industry very, very soon. And I would say it has already started. In 2026, you will see a great wave of this thing. And then do not say like, hey, we do not know these things. So this is the best time to learn all of these things. Make sense? So do not feel like this is not important. We will learn it in let's say next year, or let's say next to next year. It is not very, very popular. Just go and check the job descriptions and you will see the reality. Okay. So this was the era. Now, we know that why we need to learn RAG, and we also know the importance of RAG. That is also like evident, and that is also sorted. Now, Ansh Lamba, you said in the introduction that we do not need any kind of prior knowledge. True, I agree. So, bro, we do not even know the full form of RAG. So first of all, just tell us the full form of RAG. Okay, very good question. So RAG is nothing but retrieval augmented generation. Now I know this is a very, very, very fancy word. Trust me, this will be very clear in just few minutes. Okay. Let me put it here. And don't worry, I'm just creating these notes so that you do not need to do the hard work. Okay. You just need to do the smart work, and I will just create notes, all of these notes for you, and I will just provide all of these notes to you as well. So just relax and learn and enjoy. Okay, makes sense. So now we know that we need to learn RAG, but you cannot learn RAG directly. There are some dependencies, there are some knowledge sources that you need to first acquire. There are some, you can say, terminologies, and those things that you need to first of all understand. And why do we need to store anything in RAG if we have all the databases? You should have all of these questions in mind if you are focused so far in this video. Okay, because these are the curious questions that any developer should have. Okay, yes, all of these questions will be answered, but you should have more and more questions in your mind if you're studying RAG. Because when I was studying RAG, I was like, bro, hold on, what is this thing? Why is this thing? Okay, why not this thing? So obviously I was just referring to so many sources to gather all of that information, and then I thought, let's provide this condensed form of knowledge to my data fam so that they do not need to go here and there and need to just look at so many sources. Okay, so first of all, you need to understand the concept called embeddings that I used, okay, in the beginning. Let's see what is that. Embeddings. Do you have any idea? Like anyone, if you are familiar with this term, embeddings? Anyone? If you have any understanding with this word, embeddings. So embeddings is that particular term which is the most popular, I would say, the most popular term right now in the market. Why? There's a reason behind it. Because everything we are doing right now, it is based upon the embeddings. Really, yes, it is based upon the embeddings. So let's talk about this embeddings first of all. So now what are embeddings? So let's say you want to, let's say you are interacting with any chatbot. Okay, let me just bring any chatbot if I have. Let's say ChatGPT. So currently, you know, like every organization is trying to build chatbots, and it's not just about chatbots. Building chatbots was like an era when every industry was just focusing on building chatbots, but now they are doing amazing stuff. Chatbot is just like a piece of cake for them because it is so easy right now to build. Okay, but still, let's say you are building a chatbot not for the customers, let's say for the business. Why and how? Let's say you are working as a data engineer in your organization. Make sense? You are a developer. You want to enable AI capabilities for your manager so that, let's say, they have the data, obviously, but they do not know how to interact with SQL databases. They do not know how to work with SQL databases, or not just about databases, literally with anything, because they do not know how to write code. Not like all the managers. Some managers are good, but yeah, most of them are like, you know the answer. So they do not know how to perform all of these things, right? So now in that particular situation, you can build an AI assistant for them, and you not like you have to, because now this is a requirement in the industry. So you need to enable those AI capabilities for the non-tech people as well. Make sense? So now let's say I am the director of the company, okay? And if I say, hey, I know I have the data in my lake house, data lake, cloud, whatever. I know I have the data. I have the access to the data. I will simply say, I want to know how much sales, or let's say how much revenue we made last month. I just want to ask this question. Make sense? Now, I am using ChatGPT. Okay. I'm using ChatGPT. Okay. Let's say I am providing some context as well. So let's try to ask this question. Okay. So what I have given, I have provided the revenue details, which is like very arbitrary number. Let's say XYZ, a kind of placeholder, whatever. Okay. And then I'm asking like how much revenue we made last month. Simple. Let's try to hit enter. So what will happen? It will give us some reply, obviously. So it is saying I am missing the actual numbers here. When you say my last month, or let's say last month revenue was XYZ, could you please clarify what does XYZ present and what figures you have for the last month? Once you share the actual data, I can calculate the last month revenue for you right away. Boom. You will say, Ansh, Lamba, it didn't provide you the actual answer, but wait, that's not the intent of the question. I wrote this question using my natural language, okay? Using my language that I'm using on a day-to-day activity, English. How this machine, this ChatGPT is able to understand this thing? How ChatGPT, or basically this model behind this ChatGPT, is able to understand that the meaning of this line means that I'm providing some context, and the meaning of this line is I'm asking a question. How it knows that I'm asking this question and this is a context? See, look at the response. I am missing the actual numbers. When you say my last month was XYZ, could you please clarify? This response I would expect from a human being, because the human being can understand the context. Only human being can understand my context, like what I'm trying to say. But how this machine is able to understand that I am providing some context here, I am providing some reference, and this is my question. How? This is possible because of embeddings. Okay. This is possible because of embeddings. So what happened? When we passed, let's say I passed this input, or you can say prompt. Prompt is a very technical word for input. Nowadays, you can say prompt. Okay. When you passed this prompt, this English, it can be Hindi, it can be Telugu, it can be any language, Spanish, French, German, anything. When you pass this thing, and obviously English is the most popular one right now among AI models, but let's say you pass English, okay? But I'm so sure even if you will pass any natural language, it will work, because nowadays models are very, very powerful and strong. So let's say you pass this thing in your model, okay? You pass this prompt. So now what will happen? Not exactly this thing will go into the model and it will work. This prompt, let me just bring my blackboard. I love that. So this prompt, the prompt that we have passed. So let's say you are a human, okay? Or let's say any user. So let's say you are a user, okay? And you passed a prompt, okay? You passed a prompt, any command, anything, okay? It can be anything. Make sense? Or let's say message. Let's say you pass this message to what? to LLM. Make sense? To LLM. So let's say you pass this to ChatGPT, or it can be anything, Google, whatever your favorite model is. Okay. So I passed this prompt to this ChatGPT. Do you know what will happen? Do you know? Now this prompt, whatever message you have sent, it will go to ChatGPT. Obviously, it will go to the ChatGPT. ChatGPT, or basically OpenAI. If you have some knowledge in the AI world, I would expect a little bit of news articles that you would have read, or some post that you would have seen in AI, or let's say you have not seen anything, you are very busy. So basically ChatGPT uses you can say models called OpenAI models, because OpenAI is the parent company for ChatGPT. Okay. So let's say you have passed this prompt and it is going to the OpenAI model. Now this OpenAI model, like this OpenAI company, has so many models. So what it will do, it will convert this message, because this is the input. Okay. Let's say this is the input, or let's remove it from here. So let's say this is the input. Yeah, perfect. So let's say this is the input. This OpenAI model will convert this text, convert this English, convert this any prompt into something called as vector. It can be any vector. Let's say a kind of graph. If we have any kind of, you can say vector. Okay, this is vector. So this will convert it into a vector. And do you know what? This vector is called embedding. This vector is called embedding vector. What's so special in this embedding vector? What's so special? Why we are talking about this thing? Like this is like embedding vector, and what's so special? Let me just tell you what's so special. So what will happen? Your message will be converted using this OpenAI model into embedding vector. Now your text message is not just a text. It's not just like something very random text that you have provided. This text is converted into a vector, embedding vector, which machine can understand, which a model can understand. Make sense? So how does it look like? So it will look like a normal vector. If you have seen a vector in your school, let's say if you would have like studied about vectors in mathematics, physics, or any, I would say not in chemistry obviously, but yeah, in physics or mathematics in your school in 10th grade or whatever. So vector looks like this. Let's say you want to create a vector. So it will look like this. Let's say this is the opening braces. Then it will have some numbers. So let's say minus 1.0, then comma, then 2.3, then 4.1, and so on. So this is your vector. This is your vector. This is your vector. Okay. This is your vector. Simple. Okay. Make sense? So now how it will convert this text into the vector? That is the power of this model. That is all the things that is being done using this model. You do not need to do anything. That is why we are saying nowadays LLMs, or basically models, are actually making our life easy, because you do not need to do all those stuff from scratch again and again. So how this vector is converted? Using this OpenAI model. This is called embedding model that we have used. And don't worry, I will just show you everything with the practical thing as well. Currently we are understanding the concepts. Make sense? Okay, sorted. So we use this model, we convert it into embedding vector. Now this embedding vector will go to another OpenAI ChatGPT model, or let's say any other model. Okay. And then it will provide us the response in the form of normal language message that we have. Make sense? Or let me just remove this. It will provide me the message back to the user. Like it can be you, it can be anything. Okay. So it will provide the message to me. Okay. Makes sense. And this will be also NLP. Why? Because it has the model to convert the vector into the message. Make sense? So this is the flow. This is the flow that it will perform. Understood? So if you use ChatGPT on a day-to-day activity, you should know what is happening behind the scenes. Whatever input you are giving, let's say this is your input. This is your input. It will first get converted into an embedding vector, and then embedding vector will go to the OpenAI model again, and then it will generate the output. That's why you see that, hey, we have so many models, we have this model, we have that model. So that is why we have so many models in the market, because it depends which model you want to use, which model you want to use to get your work done. This is the power of embeddings. Make sense? So we understood what are embeddings. Make sense? We understood this. What are embeddings? So now where does this concept of embedding come into the picture? Okay. Have you heard about SQL database? Have you? Yes. What type of data you put in that SQL database? Now you will say, I put structured data. Okay. Very good. Very good. Now if I say, if you have ever heard about MongoDB, which is a very popular, you can say, semi-structured database, what kind of data you put in that? Key value pairs, similar to JSON. Okay, very good. Now if I say what kind of data you will add in RAG database, the answer is embeddings. Oh, so embeddings is nothing but, you can say, your data type that you add in your RAG database. Just embeddings? Not really. Embeddings plus metadata, because metadata is very important to manage those embeddings. Okay. Now let's see it visually so that you can understand better. So let's talk about this. Let's say MySQL. So if you have MySQL, okay, what kind of data you will add here? Obviously it will be tabular data. Make sense? You will be having tabular data. Okay, simple, like nothing fancy. Okay, so this will be like this. MySQL is mapped to the tabular data. Now if I talk about MongoDB or any, you can say, database that we use to store key value pairs, so this will be my key value pairs. Okay, do we have key value pairs? Or let me just write it for you. JSON, let's say key and value. Simple. Okay, simple. Okay, you store this value. I am not assuming that you would have worked with MongoDB, to be honest. I also haven't worked with MongoDB much. I have rarely used MongoDB because I use Azure Cosmos DB and all. But I'm just telling you that you would have heard about this term. Okay. But when I talk about RAG, so in case of RAG, you will use embeddings. Simple. Nothing fancy. Let's say -1 point something, blah, blah, blah. Okay, one very important question that you should ask. Okay, Ansh, Lamba, we know that tables have, let's say, some limits. Let's say we want to store rows and columns. Makes sense. MongoDB stores the data in the form of key value pairs. Makes sense. But Ansh, Lamba, just tell us one thing. This is a RAG, okay, and we are storing embeddings. And embeddings, we understood that embeddings are just the meanings of our text in such a form that machine can understand. And in that format is called a vector. Okay, but Ansh, Lamba, what is the size of this vector? Because let's say I have provided this input, this prompt. I know this will be converted into a vector. I know that you have explained that thing, but what will be the size of the vector? Will it be the same? Will it be different for each prompt? Or it will depend on how much text I am putting? Like what will happen in that particular case? Let's say I'm providing a huge paragraph and I'm providing just one line. Will there be any difference? Very good question if you have asked this question. So let me just tell you what happens. So whenever we use any model, remember we used OpenAI model. Okay, and let me just say embedding model. Embed model. Okay, remember we use this model. Now whatever input you pass in the embed model, okay, it can be a huge paragraph, it can be one line, it can be even one word. Each each, you can say, prompt, each prompt, when it will go to the generation model, will have the same number of the vector, or basically the same size of the vector. And what can be the size? There are multiple options that we have in the OpenAI models. A very popular one is 1536. So the size of this will be 1536. Okay. If you want to note it down, 1536. That is like one of the examples that we have, one of the models that uses. So what it will do, it will convert that text into vector, and the size of that vector will be 1536. Now what is this 1536, and from where this number came into the picture? From where? These numbers are decided by OpenAI. It is not decided by you. These are basically the features. These are basically the dimensions that OpenAI has created to convert your text into something which can be understood. Just tell me one thing. If I ask you, hey, convert this thing, or basically decode this thing, or let's say encode this thing into such a format so that you can understand. You will say, Ansh, Lamba, I can understand English. Let's imagine that you cannot understand English, or let's say you want to encode this thing to someone who can understand this, who doesn't know English. Okay, but that person understands a special language that only you know. How will you do that? You will have some dimensions or features, right? So let's say I have 1536 dimensions. I have 1536 features to convert this text into a vector. So those features can be, let's say, regarding, is this a kind of money talk? Okay. Is this regarding, let's say, animals? Is this regarding, let's say, a kind of assumption? All these kind of features, and these features are called dimensions. So there will be 1536 parameters, or not like parameters, 1536 dimensions on which we want to evaluate, on which we want to evaluate our prompt to convert it into a vector. Make sense? And there are so many popular embedding models. Let me just show it to you. OpenAI embedding model. So let's try to explore their website. So new embedding models and API updates. See, they just launch so many different models on a regular basis. So they have, okay, see how they're just converting text into a vector. Embedding is a sequence of numbers, new embedding models with lower pricing. So this is the model, and this is the model, which are the most popular ones right now. And this model has 1536, that means 1536 dimensions. And I think this is more than 3000. Yeah. But we usually use small model. Okay. But if you want richer understanding, you can use this model as well. How to use these models? Do not worry. I'll just show you everything. Okay. Do not worry at all. Make sense? So you can explore this particular blog as well, where you can see more and more things like how they're just using it. But you know what? You do not need to worry about knowing all of these things, because there are so many models in the market. You can use OpenAI models. You can use, I think, I would say Google models. There are so many models. So you do not need to worry about just these models. You just need to understand the concept. That's it. Because there are so many embedding models in Hugging Face as well that you can use. So nothing to worry. Okay. Nothing to worry. Okay. Makes sense. Makes sense. So now you know how we can convert this number, and let me just remove it because it varies as per the models that you use. Make sense? So these are the embeddings. Now we know that we store embeddings in the database. Okay. And that database is called RAG. Okay. Now I will write a word, and you should know about this word, or you would have heard about this word: vector database. Okay, vector database. You would have heard about this word, vector database. I would say vector database is nothing but RAG. Okay, so there are two popular names for RAG. One is RAG and second is vector DB. That means vector database. And there's one more word called vector store. So if you hear any word, RAG, vector DB, vector store, the concept is same, the intent is same, the motive behind that conversation will be the same, I'm so sure. So do not feel confused. Ansh Lamba, so why do we have three different words? I still remember a guy in my class, in my school. So whenever we used to study, let's say C++ in our school. Okay. So whenever teacher used to tell us like there are 2 to 3 names, but the intent is same and the meaning is same. He was like, then why do we have like three different words? If we have three different words, obviously like the purpose will be slightly different. Even the 99% of the purpose is same, but there will be like 1% difference. I was like, yeah, this guy is cool, man. And our class teacher used to laugh a lot. And I think that guy is actually right. So now what is the difference between vector DB, vector store and RAG? Okay. Let's fulfill this demand. Maybe you are that guy. So the thing is, RAG is basically the process, the end-to-end process that we follow in order to store our embeddings into the vector DB. End-to-end process. So RAG is more used for the process. That is why you hear the words called as RAG applications. You hear these words, right? RAG applications. You do not hear like vector DB applications, vector store applications. You hear RAG applications, because when they talk about RAG applications, they mean to say that we are talking about applications which will involve vector DB as well, vector stores as well, embeddings as well, retrieval as well, everything. Because what is the full form of RAG? Retrieval Augmented Generation. There are 3 steps: retrieval, augmented and generation. Make sense? Make sense? Make sense? So yes, we will talk about RAG in detail, but first of all, you need to understand vector DB. And just for your confusion, RAG is almost the same, but RAG is more used for the end-to-end process. Make sense? So can I remove this for now? Because now your confusion is gone. I can simply say vector DB or vector store. Now these are 2 exactly same. Okay, so now you cannot say, hey, what is the difference? Slight difference? No, no difference at all, because database is like where we put the data. Store is where we put the data. So actually vector store was very popular, but then data domain people came into the picture. You were like, hey, if you are putting the data into a place, we call it as a database. Don't you know this? Then they were like, yeah, that is a more cool name. So then we just started calling it as a vector database. But earlier, data people were like on the back foot, and they were like looking at the things, oh, AI, blah, blah, blah. And ML people were like leading the, you can say, space, and they were just using their own names. And then we just entered into this domain. We were like, hey, wait, hold on. What is vector store? Okay, vector store is something where we put our embeddings. Okay, so you are putting data, right? Yes. So call it as a vector database. Oh, it's called vector database. So this happened, so do not need to worry. Vector store and vector database are exactly same. Okay. So now what do we mean by vector store and vector database? As I talked about this thing in brief, let's talk about in detail. So what will happen? Let's say I want to create a database. Okay, because we data people love databases and all of these things. So vector database, we want to create a database. What is a database? Where we put our data. Simple. But in this database, we do not want to put table. We do not want to put key value pairs. We want to put vectors. Wow. We want to put what? Vectors. Okay. So within this database, we will be having vectors. Make sense? We will be having vectors, these kinds of vectors. So let's say this vector, this vector, this vector. And as I said earlier, we do not just store the vector, we also store some metadata. So let's say we can create ID. Okay, let's say we can create ID. Let's say 1 and then 2. Let's say 1. ID can be anything, right? Because you are a data person, so you would know like ID can be primary ID or whatever. Make sense? So let's say this is 1 and this is 2. And yes, we would need primary key as well here. Yes. That's why, do you know what? That's why I always tell my data fam that, hey, AI is coming, you should feel happy, because When AI was just entered into this domain, everyone was like, hey, AI will do this, AI will do that, AI will do this. But then later they realized, okay, now we have vector databases. We need people who can manage these databases very well, and we data people have mastered this skill. Okay, so you should feel happy. They do not know how to perform data modeling. They do not know how to perform like joins and all of these things. You know it better. You know it better. It is your area. They know better how to build APIs if you have not worked with APIs, but you know better the data modeling part. Make sense? And yes, 1% people are always there who know both very well, APIs and data modeling. So there are great developers in the market. So be aware. So let's say this is our metadata. Okay. And I will just show you how you can just also pass the metadata. Perfect. So this is our vector database. We have the vectors, that means the data that we have, and then we have 1, 2, 3, 4 ID. Fine. Now the question arises, and it should have arisen like very in the beginning of the video. We know that we want to store this information. Okay, this information. What are these information? Basically the vectors. But Ansh Lamba, why do I need vector store? Why? Very good question. And it's the best time to ask this question. Why do we need a vector database or vector store? Okay, the answer is in front of you. Really, yeah. Just let me show you. So let's say, let me refresh my ChatGPT page. You will say, Ansh Lamba, do you know what? Nowadays LLMs are very smart. Do you know what? If you want to ask a question, they can just answer it right away. Okay. What if I want to ask, what's the weather today? Okay. This LLM was trained maybe early this year. Okay. In 2025, early to 2025. So all the data after 2025 is not there. Make sense? Because they cannot train the model, let's say, every single day. It requires so much of computation. It requires so much of resources. So that is why they do not have those things. Okay, let me just show you. So let's say, let's go to your favorite model. Let's say you love ChatGPT, and I know that I also love ChatGPT. So let's say, let's write, why do we need vector store? Okay, this is your question. Let me just answer this question with the best way. Why vector database? Right, this is your question, right? So I will say, let's go to your favorite model. Okay, and let's ask this question from this model. Let me ask this question, and I will simply say, I will ask a very generic question. I will say, what is LLM? Or let's say, what is let's say ChatGPT or whatever. Okay, what is OpenAI? Okay, or what is AI? Simple. It will give me the answer. Obviously, it will give me the answer. Make sense? Why? Because it knows the answer. How it knows the answer? How? What is the reason behind that? Why it knows the answer? Because this model was trained, let's say, let's pick a very arbitrary date just for the demonstration, just for the education purpose. Okay, so let's say this model was trained on March 2025. Okay, so till March 2025 it has all the data, because it is trained on massive data set, like a massive. Okay, so it has this information, because obviously what is AI? It knows that. Maybe it would have trained on Wikipedia data. It knows this definition. So it will give you the information back. Very good. Now, if I ask this question, that will require this thing. So let's say I ask another question. So this is pass, by the way. Okay, this is pass. Let me just say, good job. Do we have tick? No. No. Yeah. So this is passed. Okay. This is passed. Very good. Now if I ask this question, what's the weather today? Now just tell me one thing, bro. Will it be able to answer this question? Because it is just trained on the data which is available till March 2025. Okay. So it can tell me the weather till March 2025. And nowadays it's like almost 2026. So will it be able to answer me this question? Tell me. No, no, no. The answer is no. But do you know what? Even if I ask this question, let's say what's the weather today in, let's say in New York. Okay, let's try doing this. So it is telling me cold with temperature around freezing, generally between 0 degree to 6 degree. So this is a weather in New York. Let's confirm this if it is right or wrong. Weather New York. Oh, it is accurate. Okay, it is accurate. Ansh Lamba, how did it tell you? How? So nowadays, those big giant companies identified this issue long way back. So they said like we need to enable some things so that they can also provide some information which is not available, which was not available while training. Okay, or which was not available after training. So they have access to something called as tools. They have access to the tools. That is why when I just answered this, when I just, not like I answered, when I passed the prompt, if you would have observed, you would have seen something called as searching the web. If you would have missed, just go back and check it. It showed something called as searching the web. So it has a tool called web tool. Similarly, it has so many tools: calculator, web, news, search engine, so many other things. So it has all the tools available. That is why ChatGPT is able to tell you what is the weather today, because it just applied a web search. The same way I searched on Google, it also searched on Google or any search engine. And then it gave me the answer back once it had the information from the search web. Okay, this is also sorted. This is also sorted with the course of time. Earlier, like, it was not possible. By the way, let me just tell you, it is just recently added, or maybe this year. It was not there before. But now there is one more problem which cannot be solved, and which I would say cannot be solved. Cannot be. Let me just tell you what is that problem. And it can be only solved with the help of vector database. So let's just tell me one thing. Okay, it has tools, everything. Okay, it has tools, it has everything. Now, if I ask this question, if I say, let's say your manager or director wants to ask this question from the ChatGPT, how much revenue we made? Okay. Now just tell me one thing, which tool it will call to answer this question? There is no tool available. There is no tool available. It cannot answer this question. It cannot. It cannot. This will throw the error. Not error, basically it will say I don't have any kind of information with this thing, so it is not possible. So here, what we can do? We can create our own vector database. What? Vector database. Okay. So what will happen in this case? I will say, okay, it is not possible. Let me just provide you the solution. So I'll simply say solution with vector database. Okay. Solution with vector database. So what we will do, we will call the same LLM, but this time what we're going to do, we will add something magical. We will simply say, hey bro, we want to ask this question from you, but do not feel alone, because we are with you to help you, and we will provide you some magical things so that you can answer it. So this time what I'm going to do, I will provide something called as a database. Okay, this database. I will provide this database. Okay, make sense? I will provide this database. I will say, bro, this is my database. I have created this being a data engineer, being an AI engineer, being an AI data engineer. I have created this vector database. Okay. You can use this to retrieve the information. You can. This is called RAG. Or basically, you can say this is called vector DB. But this whole process is called RAG. Okay. So this is my vector DB, let's say. So now this vector DB is available to this LLM. This LLM. Make sense? Okay. Now this problem is solved. Now you can ask any question for the information which is inside this vector database. Ansh, Lamba, hold on. Why do we need to make our information available to this model? Why? So the answer is, bro, that is why we are building RAG databases. So there are two options. If you open your ChatGPT, you will see that I can upload so many things. If I click on attach, I can attach maybe my company's reports, anything, right? That's what you can do if you are doing something for your own personal use case. Let's say you want to just upload your own profile photo or anything. That is for your use case. But obviously companies do not want to upload their information on OpenAI platform or basically ChatGPT platform. Because whatever you will upload here, ChatGPT will do the same stuff. That will be converted into a vector database and then it will use that vector database. But that information will be available to them. But you do not want to make it available. That is why you do not upload anything here. You do not use ChatGPT. You use only the model behind ChatGPT. Let's say you want to use GPT 5.1, 5.2 is the latest one. We can also use that, don't worry. So you want to use the models behind it. Make sense? You want to use the models behind it. So if you want to use the models behind it, you can create your own vector database and you can make the API calls to this model to get the response with respect to this vector database. And this whole process is called RAG. Make sense? Make sense? Make sense? This is your vector database and why vector database and what problem it tries to solve. Make sense? I hope it makes sense. Okay. Now let's say in this vector database, you have your PDFs, revenue PDFs. Yes, you can store anything, revenue PDFs. Let's say you have, YTD sales, you have Excel sheets, you have text files, anything, bro, anything. Let's say you have all of this information available. You can upload literally anything. Just look at the power. Make sense? It can be anything. And now it will be able to give you the response back. Okay. Make sense? I hope it makes sense. That is the flow. That is the flow. So this is the solution that vector database provides. Make sense? Okay. So now it's time to look at the RAG process, because we understood what we are trying to do, why we are trying to do, how we are trying to do, how not in detail, but yeah, concept wise. Now we need to see everything step by step happening, like how we can just do all of these things. So now we need to say RAG and to end process. Now we are just talking about RAG end-to-end process. Okay, make sense? So now we know like what is RAG. Okay, we know what is RAG, but I can still like write the definition for you if you want, just for your notes. So RAG is a technique Wow. Perfect. So RAG is a technique that combines document retrieval with generative models, which are LLMs, to answer queries using both external knowledge and language generation. What are external knowledge? This is external knowledge. And language generation, that means the data, the knowledge that it already has. Makes sense? This is the end-to-end process, but there are some steps involved. There are what? There are some steps involved. So we perform RAG, as we all know, but there are basically 5 to 6 steps involved before performing the RAG. Okay, what are those steps? Let's talk about those steps in detail and let's try to understand it. And this is the area where you need to put double focus because you need to understand all the steps carefully. Okay, let's try to understand it. So the first step in the RAG process, again, you need to be more focused because see, first that you need to understand the whole process, obviously. Second, we have a detailed, I would say the rest of the section or basically the rest of the video is pure hands-on, pure lab. We're gonna just do everything that we have learned here, much more than that. But why I didn't show you, why didn't I show you the lab in the beginning? Because I want you to first of all master your fundamentals. I want you to just master the concepts first of all. Make sense? Only then you should be implementing these stuff. Currently, I know a lot of people are just focusing on implementing. Yes, it is good, but you need to understand the, I would say fundamentals first of all, so that you can learn any technology, any vector store, any vector store, anything easily. Make sense? Okay, very good. So now let's try to understand RAG step by step. Okay, what are the steps involved? So first of all, the step number 1 is in the RAG. What is this? So the step number 1 in RAG is step 1. It's called document preparation, basically input. Okay. Document, let's say document preparation. Okay. Or let's say document input, whatever. Let's say document input. Okay. What kind of document? It can be anything. PDF, whatever. Okay. So let's say you have this document. Okay. And it can be anything again. Okay. Any file, anything. Okay. Makes sense. So you will prepare this particular document that you want to add. Can we only add one document? No, you can add multiple documents. You can literally add multiple. You can even add files. You can even add images that would have some kind of textual data within anything, literally anything, bro. PDFs, books, ebooks, anything. Okay. Do we have PDF? No. Do we have file? Okay, let's add this one as well. Okay, so let's say you have this data that you want to add. Maybe this can be your monthly revenue, YTD sales, whatever you want to add, okay, in your company, in your organization. It can be your own personal application as well, but let's say you're working in an organization and you are building a RAG application for them. So step number 1 is document input. You have all of these documents available. There are 3 documents. Perfect. Now the step number 2. Step number 2 is very important. Step number 2 is called getting the text. Okay, getting the text. So basically converting into text, or I will say document input to text, because it is like step 1 itself. So document input to text, because we simply fetch the text out of everything, images, PDFs, everything. Now you will say how we can just fetch the text from the images. There are so many models which can easily fetch text written on the images. Okay, fine. The second step is chunking. What? Chunking. So what we do in the step number 2, we create chunks. Why? Okay, let me just tell you why. So let's say this PDF, this PDF has 10,000 pages, which is a very common thing. If you, let's say you put any e-document, or let's say any e-book, it would have, let's say 10,000 pages. It's not a very big deal. Okay. It's very common. Let's say it has 10,000 pages.
Images, there are like so many images. Okay, let's say there are 100 images. Okay, 100 images, and then this particular file has, again, I would say, let's say 20,000 pages. Okay, makes sense. It is common. If you just look at any documentation, let's say you want to build a RAG application for any platform, there are so many documentation, right? And you need to put everything. So let's say you have everything. Okay, now if I ask you that do not perform chunking, okay, let's get rid of it. If I ask you, hey, just upload the whole file, okay, and create a vector for this, obviously you will do that. It's not a big deal, you can do that. Okay, but you know what, you simply pass the context. You know that you will pass what? You will pass context to the LLM whenever you will be asking some questions. Make sense? So just imagine that whenever you are asking any question, you are putting this much of context size every time. 10,000 pages, 100 images, and 20,000 pages. Just look at your token size, because see, whenever you're making the API call to any LLM, you are spending some tokens, you are spending some money. So in each query, you are sending 10,000 pages from one file, 100 images from the second source, and 20,000 pages from the third file. Can you imagine the token size for every query? Your manager will be like, bro, we do not need any kind of RAG, just we do not need any kind of AI capabilities. So what we do not like upload this data as it is and create vectors out of it. No, we create chunks. We create what? Chunks. So what will happen? I will take this input, okay, and I will create multiple chunks. Okay, I will create chunks like this. Let's say chunk number 1, okay, chunk number 2, chunk number 3, and so many chunks. Okay, so many chunks. So these will be my chunks. What will be the benefit of it? What will be the benefit of it? The benefit is very, very, very simple and very straightforward. Now let's say you have these chunks, right? Chunk 1, chunk 2, chunk 3. Make sense? Now let's say you want to pass some context. Okay, you want to pass some context. Now what will happen? You do not need to pass all these things. Now LLM will pick the relevant chunks only. Let's say you asked a question, how much sales we made last year? This is your question, and you know that particular answer is available in this particular PDF and on the very first page. Okay, so now we have a chunk for it. Chunk means like small chunks. So LLM will only and only pass this chunk. Let's say these two chunks. Let's say the question that you are trying to ask is available in these two chunks. So only these two chunks will go to the LLM. Only these two chunks. That's it. Now the question arises, how LLM would know that only these two chunks are required? I will just tell you in just a few minutes, because that step is the forthcoming step. Okay, makes sense? Okay, so you need to understand the concept, why we are doing the chunking, because you do not need to pass the whole PDF again and again. Hey, you want to know my sales? Okay, just take this PDF, just take this whole PDF, 10,000 pages. Yeah, and then your director will call you, bro, come here. I need to just see you in the office. So if you want to ignore these things, you need to make your applications efficiently. That is why I'm telling you, you need to understand the concept before directly implementing the solution. It is so easy for me just to take any small PDF of 10 pages and I can just show you the code, and you will be like, hey, we know how to make RAG applications. And then you'll be sitting in the interviews, then they will just ask questions regarding this. Or let's say you are hired, you are working on a project, then your director is calling you, hey, just meet me in the office. I do not want all of these things happen to you. That is why I'm just creating this detailed masterclass so that you can understand everything. Okay, makes sense. Now you know why chunking. So okay, why now we have performed chunking. Now we have these chunks. Okay, now these chunks will be converted into what? Converted into vectors. Okay, which is called embedding. Embedding vectors. Okay, embedding vectors and mapping, I would say. Why embedding vectors and mapping? So what will happen? These chunks, okay, these chunks will get respective, you can say vectors. Okay, so let's say this will be called as this vector. Let's say 1, 3 point something 6 and blah 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 blah. Okay, so this is vector number 1. Okay, and this vector is mapped to what? This chunk, right? So this mapping needs to happen. So what will happen? LLM only understand this thing. LLM only understand this vector, but you need to make sure that whenever LLM is referring to this vector, that means we are referring to this chunk, because you need to pass the chunk, right? The text. Make sense? So all of these things will be happening in this particular step. Make sense? Okay, good. And obviously there will be a different vector for each chunk. I'm just repeating this step so that you can just understand it. Okay, so step 3 is also done. Now step 4 is very simple and the most easiest one. Once these embeddings are ready, simply store them in the vector store. Storage. Perfect. Storage. So now your database will come into the picture like this. So now you need to store this thing. Okay. Wow. Where is my database? Perfect. So this step is the most simplest one, but yeah, most important one as well, because you need to store these embeddings. Okay. Perfect. This is also done. Step 4, storage. Now step 5 is search. Okay, step 5 is search. Now what will happen? Let's say you have the database ready. Okay, you have the database ready. Now what will happen? You have the database ready. Now a user will come into the picture. Okay, user will say, bro, I want to ask this question that you have, or let's copy the diagram that we built here. Yeah, perfect. So now this user will come into the picture and it will say how much revenue we made. So what will happen? This search will happen. This search will happen. This is important. This search will happen. So now what will happen? This LLM, remember we just mentioned that how LLM will be able to fetch only the relevant chunks. How LLM knows like which chunk is relevant. This is the step for that. This is called search, or basically semantic search. Semantic search. Okay, semantic search. So what will happen? It will say, bro, you want this information regarding revenue. Okay, and LLM now has access to all the vectors. Okay, makes sense. So now what will happen? LLM, okay, will fetch top 3 chunks by default. We can pass the number as well, but let's say you are passing the number as 3, that you want top 3 chunks. What it will do, it will apply a method called cosine similarity. Okay, it will apply this method called cosine similarity. So your input will be converted into a vector. Obviously you know the step. Remember the flow I talked in the very beginning, that it gets first converted into a embedding vector, right? Where's the text color? Okay, so it will first get converted into an embedding vector. Remember? Okay, perfect. So now this input will be converted into a vector. Make sense? Okay, before reaching it here, so I can simply shorten it and I can simply say it will be converted into a vector. Okay, perfect. How much revenue we made, and this will be converted into a vector. Make sense? Okay, let's copy this. Okay, perfect. So this will be converted into a vector. Make sense? Okay, perfect. So this will be a vector as well. Make sense? This will be a vector as well. Okay, now what will happen? What will happen? This vector will go to this LLM. Okay, this LLM will apply semantic search or basically cosine similarity between this vector and among all of these vectors. Top 3 vectors which will be most similar to this vector will be picked up. So this will return, let's say, 3 vectors. Let's say 3 vectors. So these are the 3 vectors. Okay. Or let's copy this. I hope you are understanding the thing that I'm trying to explain. Perfect. These are the top 3. These are what? Top 3. Okay. And how it knows? Using cosine similarity. So these top 3 vectors will be mapped to their respected chunks. If you remember, we have respected chunks, right? Let's say chunk number 1, chunk number 2, and chunk number 3. Okay. These chunks will go to the model as a context. This is the entire process. Okay, these are the chunks, or you can say text chunks mapped to these. So this will be the answer of this cosine similarity, which will go back to the model. And then model will return the response. Make sense? Model will return the response. Let's expand this diagram so that you can understand it better. So this will pass this thing to vector DB, and this will return this answer, cosine similarity, and then this will go back to the model here, and then this model will send the response back to you or whatever who asked the question. Perfect. Make sense? This is the entire flow. Okay, because now this model has this chunks, okay, plus your question. Now it has the bundle of everything. Whatever it needs, it has. Whatever. So now this model will be able to answer a question using this thing. This step is very important. And the best thing is you do not need to do anything in this step, because this will be like automated, but you need to understand what's going on behind the scenes. Make sense? This process is called RAG. So now once you have this thing, it will return back back the results to you, and it is called RAG process, end to end. Now you will say, Ansh, Lamba, we have this word called RAG, which is called retrieval augmented generation. We have read so many articles where we just talk about, hey, these are the 3 different steps. Yes, these are also 3 different steps, but they are grouped together. When we say R, retrieval, so all of these things till here are retrieval. And we can just also explain this retrieval step here in the semantic search, because all are the prerequisite steps. So when we say retrieval augmented generation, this is called retrieval. This is retrieval. When we retrieve the relevant chunks. Okay, this is called retrieval. Okay. Let me use this. This is called retrieval. Okay. Okay, makes sense? This is called retrieval. And what is generation? This is generation because it generated the response. Or what is augmented? Augmented is this one. This one. Why augmented? Augmented means when you enrich something, when you provide some more context to something. First we retrieved it, then we augmented it. How we augmented it? We simply provide some richer context, and this is called generation. This is called generation. I hope it makes sense. This is your generation because it generated this message, or basically the output. Makes sense? This is the entire flow. Retrieval, augmented, generation. This is the entire process. This is the entire process. And whatever steps we perform before, these are the prerequisite, or you can say the backbone for RAG. And this whole process is called retrieval, augmented, generation, end-to-end process. Make sense? Understood? Understood? Now you know why we do chunking. Now you know why we just perform those semantic search. It's not just like copy pasting the code, whatever written in the documentation. You need to understand what's going on. So this is the entire process. Now your fundamentals are strong. Now your concepts are strong. Now let's see how we can just perform all of these things in the code as well. Now let's see. So I have just re-architected this so that it can be like easily displayed in one go, because the previous version was like so vertical. So I think now it makes a little bit more sense. Okay, just for your better understanding. Okay, makes sense. Okay, so now let's see our coding part, our lab part, how we can just do all of these things, because conceptual wise you are strong now, but you need to be strong from the coding and from the implementation perspective as well. Okay, let's do it. Will be a lot of fun. Let me be very honest, we're gonna try and test so many things, and let me tell you one thing, I'm gonna try so many things that I haven't even tried, so I'll be just trying with you. So it will be like lots of fun, because RAG is like growing so rapidly. Okay, so there were like so many things on my list, so I was like, let's do it with my data fam, and let's see the errors together, let's see the things together, and let's do everything together. Okay, let's do it. So now let's talk about the implementation. Okay, very good. Before starting with the implementation, there are some things that you would need, or I would say I would expect from you that you would have. Okay. As you know that we are going to work with real world use cases. Okay, we'll be just making some API calls to the models. We'll be using some amazing industry level models. Okay, so I would expect something from you. Okay, and not in terms of knowledge or anything, but some resources. The first thing is, which is called OpenAI API key. Okay, I would need this because I will be making API calls. So I need OpenAI API key. This is the first thing. Now, is this API key free? It used to be free, but now they have started charging some money. Basically, let me just give you the, you can say, overview how you can just create your OpenAI API key. So basically, whenever you make an API call, you spend some tokens. Make sense? You spend somewhat tokens. Okay. They are not asking you to pay X amount every month. No, they are saying, see, you want to make API calls, it's fine. You just need to have some amount in your account. Let's say $5. Yes, literally $5. You can start with, I think, 5 or 10 bucks. I think $5. Yeah. You can start with $5. You can add those credits in your account, and then you can just make those API calls. Ansh Lamba, will $5 be enough for this video? Like for this particular, whatever we will be making API calls? I would say, my lovely sister, my lovely bro, $5 will be more than enough if you are just doing it for the learning purpose, because you will be making API calls. Okay, I know. Even if you make so many API calls, you can easily expect that $5 will be like more than enough trust me. And you can even watch so many other videos, tutorials, courses, and then also your $5 will remain in your account. Like you will have some balance left, because with the course of time, LLM models are so good that you do not need to spend so much of tokens to make those simple API calls. So it's very cost efficient. You can just trust it, and obviously decision is yours. Okay, I cannot force you. I cannot say, hey, just go with it. It's totally up to you. I'm just giving you the reality check that you would need this OpenAI API key to make those API calls, and you can start with the amount called $5. Simple, sorted, very good. There is a free version available as well, okay, which is called Docker model runner, which is a very new thing. Okay, Docker model runner, DMR, where we can access open source LLMs, open source models to do the same stuff. But my recommendation to you would be this one. Just go and create API keys, because you can use modern days models. Okay, you can use most proficient models to do the work, and you can obviously like see the major difference. But I'm just giving you both the options, because I don't know if you will not be able to go with this option due to any reason. I do not want to know any reason, and I'm not interested. So I will just show you this option as well, Docker model runner. But if you ask me, like, Ansh, what is your recommendation? And if we want to follow your recommendation, my recommendation is this one, OpenAI API key. Simple, sorted, very good. Now along with this, you would need VS Code installed on your machine. Okay, I would expect this. VS Code, and I would expect you have Python installed as well. Okay, and if you are in the data domain, I would say these are those things that like, what to say, man. I would not even need to mention all of these things, because these things should be in your machine, right? So I would need VS Code, I would need Python, basic stuff, and I would need OpenAI API key. I can use Google Colab as well. Okay, that will save a lot of time, but I want to give you the real world exposure, like how we build RAG applications in the real world. Like we are not building like RAG applications, but even if we are just understanding what is RAG and we are just trying to build very basic implementation of RAG, you need to know the best practices, how we just manage API keys so that you do not misuse your API keys. Because see, you need to store those API keys carefully, because they can be misused, right? So I will just show you all of these things. We can manage OpenAI API keys in, or basically any API key in Google Colab as well, but I just want to give you the real world exposure. If you are a fan of Google Colab, I am also a fan of big fan of Google Colab, but I will just show you this thing with VS Code. But due to any reason, if you do not have VS Code installed, if you do not have any Python installed, you can use Google Colab. Google Colab is a free hosted version of Jupyter Notebook that you can use. Make sense? But I will be using VS Code and Python on my local machine. Okay, because I want to show you this thing as well, Docker model runner. Sorry. Now, this will be our primary stack. This one recommended. Okay, this one is recommended, and you can still even go with this one as well. Okay, you can go with this one as well. I will show you how, but recommendation is clear. Recommendation is this one. Okay, so now it can be the case that you will not even have Docker installed on your machine. Okay, so this particular section, this small section of the video, is just for those who want to use Docker, but who want to use OpenAI API key, they do not need to do anything. If those want to use Docker model runner, what they can do, they can simply go to any browser and just simply search. Let me open an incognito window. Okay, and if I search Docker tutorial for data engineers, I have created a video recently, very recently. I'm not asking you to watch the entire video. Okay, so let me just search that video. Okay, here it is. So this is uploaded 6 days back. Okay, so if you go to the description, you just need to click on this chapter, Docker installation. It is just, I think, 10 to 15 minutes long. That's it, this particular section. You can watch this video so that you can download Docker. You will say, Ansh Lamba, we can go to Google and we can download Docker. Docker installation is not that much easy. You need to do so many other stuff along with the installation. So you can watch this 15-minute section, okay? And then you can download Docker easily and make sure it is up and running. Okay, it is just for those who want to use Docker going along with this video. If you want to use OpenAI API key, then it's fine. You do not need any kind of Docker video or Docker installation. Make sense? Okay, very, very, very good. Now let's get back to our discussion. Okay, so now once we have all of these things, we can get started with our implementation. Okay, these are the prerequisites. Let me just highlight is that prerequisites. Okay, prerequisites. Okay, makes sense. Okay, so once we have prerequisites achieved, we can get started with the code. So let me open my VS Code and let me open my Python environment within VS Code and let's get started. Okay, Ansh Lamba, you solve the problem for others who are using Docker. What about us? You didn't tell us like how to create OpenAI API key. Okay, so sorry for that. Let me just tell you. Simply go to your browser. Okay, and let me search OpenAI API key, or basically OpenAI API. Simply search this. This will take you to this platform called openai.com, not chatgpt.com. Okay, this is totally different. API platform. Go here and this is your platform. Okay, this is the platform from where you can create the API keys. Make sense? So if I go to login, okay, and then I can go to API platform. Okay, you do not need to go to ChatGPT. Simply go to API platform. Create an account if you do not have an account in OpenAI. Create the account. ChatGPT is totally different, bro. I'm telling you. Okay, do not get confused. This is OpenAI. So go to API platform. Okay, and then you just need to log in. And here you can just put your email ID or whatever Google account. Okay, once you do that, then I will just show you my account. Okay, let me just show you that, and you can even see the API pricing here. Here you can see $1.7 per 1 million tokens, and this is the best and the latest model they have launched called GPT 5.2. This is the most expensive model they have right now. Not like most expensive, but this is the most latest one. Most expensive is this one, the smartest and the most precise model, which has $21 per 1 million tokens. But you know what? We can use GPT-5 mini, which is so cheap. Just look at the price, $0.25 per 1 million tokens. Wow. 5 mini. Okay. So you can just use this as well. Like we can just use any model. Okay. And then we have some 4.1 models as well. I was using 4.1 mini, or I think nano, because nano is very, 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 very cheap. See, $0.2 per 1 million tokens. 4.1 mini is like almost same, and O4 mini is like a little bit expensive, but I think I should use this one because this is, I think, the best one, GPT-5 mini, and it has $0.25 per 1 million tokens. Okay, so now once you have created your account, let me just show you how you can just create the API. Okay, let me show you. This is my account. Okay, so in order to go to your account settings, simply click on this settings button. Okay, once you click here, you will land on this page called API keys, as you can see it here. And then you will see this section where you have all the API keys. Currently, I have just one API key that I created, I think, few days back. Yeah, I think just yesterday. Yesterday? No, not yesterday. March 19th, I guess. Yeah. So this was last used yesterday. So I created this API key in the March. I just keep on revoking and creating new API keys. You can also do that. So just for this tutorial, let's create a new API key. Okay. So you can click on create new API key. I can simply click on plus new. I can give a name. Let's say I want to give it a name, RAG tutorial. Okay, RAG tutorial YT. Project, I can keep it as default, and the moment I will hit create secret key, it will create a secret key for me, and you will also see the entire secret value, and you just need to copy and paste that value in your secured place, because once you copy it, it will be gone. You can say copy and paste it. If you want to use an API key, if you didn't copy it at that time, you have to create a new one. So the moment you hit here create secret key, make sure you copy and save it in your text file. Wherever you want to send it, you can just send it to your loved one. Hey, just keep it secure because you are the most trusted person in the entire world for me. Whatever you want to do, whatever, I do not care. Just save that key. Okay. So as you can see, I have created this API key and it is here, and I have saved it as well. Okay. I didn't send it to anyone else. I have saved it in my notepad. So when I'll be just using it in my VS Code, I will just show you how you can efficiently use it with the best practices. Okay. Good boy, good girl. So now we have all the API keys sorted. Okay. Now let's go and try to see the models, like whatever models do we have. Okay. So if I go here in the pricing, or not just pricing, we can just check the pricing from here as well. So if I go to, let's say, pricing, basically the models that we have, I have already showed you. Okay. But still, let's say I want to see the models. Let me just show you. Click on, I think, your project or dashboard. Yeah. You can even, I think, click here in the API reference. And then if you just go to the models, you will see that, yeah, this way we can also list all the models available. But you know what I prefer? I simply search on Google and I simply say, open AI models. That's it. And that way I directly land on the desired page and see I have all the models. Okay. So here are the new models 5.2, 5 mini and all the things. Let's click on pricing so that we can compare it. So perfect. This is the thing that I personally do instead of just making the API request just to get the models. No, bro, no. We simply go to the web page. So I am going to use this one. 5.2, 5.2 mini. Oh man, this is so cheap. See, GPT-5 Nano. I will use this. So this is just charging $0.05 per 1 million tokens. Per 1 million token, just $0.05. So you can imagine that how cheap it is and your money will be worth it. Okay. So let's try this GPT-5 Nano. Earlier I was just thinking let's use 5.2, but yeah, I think let's use 5 Nano. It's fine. Okay. So let's use this one 5 Nano, and you will be saying like, hey, we have created the API key, but how to just recharge it? That's a very good question that I just skipped it. So let me just tell you how you can just recharge your thing. If you go to, let's say, settings. So in order to just do the top up, or you can say just add the credits, simply go to settings and then click on billing, and here you will see overview, which is this one. So I have some amount left in my account and I can even add more credits if I want, and even I can cancel it as well anytime. Okay. So there's an option for auto recharge as well. This is for those who are building some live applications, live products, which will be like used for, let's say, 24/7 API calls, but we are just doing it for learning purpose. So you can simply go to payment methods and you can just add some balance. And I think in the overview tab as well, you will have the option to add to credit balance. So here you can just add, let's say, $5 or $5, $10, whatever you want to do. And then you can use it using this model called pay as you go. So it will not be just like charging you $5 every month or $10 every month. No, just recharge it, let's say, one time. And if you do not use it, it will be there in your account. It is there for you. Make sense? I hope now it is like all clear how to create OpenAI API key, how to recharge your account, and how to select the model. And we will be using 5 Nano. Okay, GPT-5 Nano. Make sense? So I think you have everything to get started with the implementation. I know these are some kind of boilerplate, but see, you are learning a new technology, you are learning something very, very new. So you have to do all of these things, right? It's not like just go to Google and do all. No, you are using the solutions, or basically you are building a solution which will be used by so many businesses. Make sense? Okay. So let's get started with our implementation. Now I assume that you have API key, you have saved it in the system, and third thing, you have balance ready. Otherwise it will throw the error that you do not have permission, you do not have balance. So just make sure that you have some balance here so that you can make the API calls. Sorted? Okay, very good. Now let me just open my VS Code editor quickly and let's get started. So here I have opened my VS Code editor. You can also open yours and let's get started. So I have created this folder called rack tutorial. Okay, you can also create the same folder or even whatever you want to keep it. In your case, I have just kept it simple. Okay, so let me just have some more space. So this is an empty folder. As you can see, there's nothing inside it, fully empty. I will be just showing everything to you in front of you. Okay, so first of all, we need to set up the environment, basically the virtual environment. We have Python installed. We know that. I have already told you that you need to install Python. And I can assume that you have followed that step. Okay, good. Now we will be creating our virtual environment. Why Anshlama virtual environment? Can't we just work directly in the global environment? No. Why? Because we will be installing so many packages and I do not want to install all the packages in your global environment. That is not a good practice. So we always create a virtual environment whenever we are working with anything. These are very, very fundamentals, but still, I was thinking let's share this knowledge as well. So in order to create a virtual environment, I will open my terminal, and how you can just open the terminal, you can click on these three dots, then terminal, and then new, or you can say Control Shift and tick. So this is my terminal. Okay, good. Now there are two ways to handle this project, to handle everything. The earlier or traditional way to do everything was pip. Pip was the package manager for our all the Python projects. But we also have something called as UV. What? UV. Okay. I will be using UV. You can use pip if you want to. What's the difference? Nothing, but UV is more modern approach and you should also learn about it because you will see UV in all the projects. Okay. So now, if you do not have UV installed in your machine, you can simply say pip install UV and hit enter. It will install UV. In my case, it is already there. In your case, it will download UV. Make sense? Okay. Then I can say UV maybe version minus V, or maybe UV version like this. Yeah. So you can see I have version 0.9. This will make sure that you have the download, that you have downloaded the package successfully. UV hyphen hyphen version. Let me just clear out the stuff. Perfect. So from now onwards, I will be using UV instead of pip. Nothing major difference, but I love UV. You should also love UV. UV solves a lot of problems. Let me just show you. I want to set up the project, so I don't need to create anything manually. I will simply say UV init and hit enter. It will create all the basic things for me. It will initiate the get for me. It will initiate get ignore. It will initiate Python version. It will initiate one demo Python file. It will also initiate toml file, which is for building packages. It will also initiate one readme file. I know we do not need all of these things, but it's a good practice to have. Do you need Git? No, we are not discussing Git. If you do not have Git, do not worry about that. Make sense? Good. Now we need to create a virtual environment. In pip, we used to create virtual environment like this. Pip, Python minus m, then virtual environment, then name of the virtual environment. But here you just need to say uv, ve, nv, and the name of the environment. Let's say I want to create .ven. Hit enter, and I have created this virtual environment called .venv. Now let's enable it. It has also given me the command, hey, you can enable it with this. Yeah, I know that. So I'll simply say .venv scripts and then activate it. So here my virtual environment is activated, as you can see, .ven, and this is here. Perfect. Very good, very good, very good. Simple. Now we will be creating our first chapter for this RAG. Okay. I'm not forced, like let's say we can create notebooks, obviously. Okay. We can create folders as well, but I don't need to create folders. So what I can do, I can create a notebook. Click on this new file and I will call it as 1.1, or basically you can say 1.0 underscore rag. Basically, I will say rag with own text. Okay, rag with own text. .ipynb. .ipynb is the extension for Jupyter Notebook. Hit enter. This notebook is created for you. Wow. Let me just turn off this terminal. It is not required anymore. Okay, so this is my notebook. As you can see, rag with own text. What does it mean? I will just tell you, don't worry. This is my notebook. Perfect. This notebook is created. Yes. If it asks you to download the IPy kernel, just say yes, because that will be required to perform anything with the Jupyter notebooks. Sorted? Good. Now you also need to create one file. It's called .env. .env. This is the file that we create to store our secrets because these are kind of environment variables. Okay. I will create an environment variable called OpenAI API key equals my API key. In your case, it will be your API key. Make sense? In your case, it will be your API key. In my case, it is my API key. So I need to write something like this and my API key. Obviously, I will not show it to you. Okay. In your case, you can fill it on your own. Make sense? Make sense? We also create one more file. It's called .env.example. Why we create this file? So that let's say I am pushing this whole thing to my GitHub so that you can use it on your for your projects, right? So in that case, obviously you would need to know what are all the environment variables you need to create in order to run this application. So what we do, we simply create a demo version of all the environment variables. So I will simply say OpenAI API key, same variable, but the value will be demo or pseudo value. Let's say asterisk asterisk asterisk. Let's say like this. So we save this thing, but we do not save anything here. Okay, we do not save anything here, but obviously like I would need to just store my API key, but this will not be the part of my project. Why and how? Go to git ignore and you will see that I can put something like this environment variable file .env and let's save it. The moment you will save this file, this will be grayed out. That means this is not the part of the project. So the moment I will deploy this code to GitHub, you will not see this file. So that this actual variable or basically actual API key is not exposed to you, but you have the example file available so that you would know what are all the API keys you need to create. This is a kind of best practice we follow in the industry. So let me pause the video here and let me just put my original API key so that I can start the work. Okay, let me do it. So as you can see, I have put my API key as well, and obviously I have not shared the whole screen. I have just shared a very small part of it. Let me just expand it more. Yeah, so but yeah, you need to just store your value like this in your .env file. Make sense? Very good. Now I can just close this file. I don't need this file. Perfect. So now let's start with our development. So we have all the files ready that we need, okay? And we can now get started with this particular notebook. What do we actually need to do in this notebook? We first of all need to load that environment file in our current notebook. And even before that, we need to select the kernel. So just click here in the select kernel and just select Python environments and then just pick your .env because this is your virtual environment. You cannot pick the global environments because if you pick the global environments, you will not be having access to the libraries that you will be installing in this environment. Click here and that is done. Perfect. Now we need to follow all the things step by step that we have learned, right? Okay, makes sense. Let's start our code like we start our code with the imports, right? Go to code. This way you can just enter the code and I assume that you would have some basic knowledge of Jupyter. Okay, if you do not have, do not worry, I'll just show you. So see, that's how we just enter the code cell, and whenever we just write anything within this, it will be executed cell by cell instead of executing the whole notebook. So I will say import OS, which is my OS module, very popular module in Python. I will import from load, not load, I think maybe environment something, maybe dot environment. Yeah. So I need to import this package. So see, as you can see blue line here, that means this package is not installed. I need to install this package. I will open my terminal. I will add this package. Usually we do it like this, pip install, whatever, right? But I don't need to use pip install. I will use UV. I will say UV add and then the package name .env. Hit enter, it will add this package and now the problem is resolved. So load .environment package is the package we use to load our all the environment variables. And there is a function called load .env. The moment we run this function, everything which is here, everything which is here will be loaded in your current notebook, current file. Everything, all the variables. Really, yes, you can even see those variables and I will just show you. Okay, let's try to run this thing. So see, it is asking me to install IPy Yes, install it. It's fine because it always asks you to install IPy kernel. It's a kind of package that you would need. Okay, connecting to kernel and that's it. So it is good. Perfect. So it is importing OS and everything. Let me run it one more time. And in order to run this, you have two options. You can even click here or you can say shift plus enter together to run this cell. Okay. So as you can see that it has returned true. That means it is completed. Now that means all the environment variables that we defined here are created in this particular notebook as well. That means we can use it because whatever code you will be using to make API calls or whatever, you will need those environment variables. And I can even show you. I have an environment variable which is called like this. os.environ and environ variable is OpenAI API key. Okay. I want to print this. Obviously not print this. I would say if this is available, print API key is set. Okay, that means this environment variable is created. See, that is why it is saying API key is set. I can even paste it here so that you can also confirm it API key is set. Otherwise, you need to fix something. Something is wrong with your code. Okay, good. So now we have this code ready. Now we need to import some more packages. It's called LangChain. Now you will be very, very happy. Oh, we are just using LangChain. Yes. Because LangChain is that package which is a kind of most widely used agentic framework package, which makes the life so easy to work with so many models. You do not need to follow any specific API key syntax for OpenAI. You do not need to switch your code to different API key format. No, nothing is going to be changed because LangChain will handle everything. There are some packages that you need to install. For example, let's say from LangChain OpenAI. Okay, LangChain OpenAI. We need to import chat OpenAI. Now this package is not installed. That means we need to install this. Obviously, there is one more package that we will be installing from LangChain community, I guess, and LangChain core as well. Yes, LangChain core is like one of the very popular packages. Let me install all the packages together so that you would also not face anything. UV add LangChain and then OpenAI, LangChain core and LangChain community. Hit enter. Okay, what is this? LangChain open was not found in the package registry. Really? Oh, I just wrote LangChain open. It's not LangChain open, it's OpenAI. Okay, let's hit enter again. And what is stopping it? LangChain OpenAI. Okay. What is the package name? LangChain OpenAI was not found in the package registry. Python version 3.13. No solution found when resolving dependency of select markers. Projects comments and oh, I see. Just add the package one by one, just to ignore any kind of conflict. First, get started with UV add LangChain OpenAI, and as you can see, it is installed and has installed all the dependencies. Now let's add the other one, UV add LangChain community. Hit enter. It is done. Then UV add, I think, LangChain core. Perfect. Do it one by one. Do not do it all together. You will be saying, Ansh, Lamba, where are our package stored? So if you open pyproject.toml, you will see all the packages we have installed listed here. See, in the dependencies. We can also generate requirements.txt file if you want. You can simply say uv pip, let me say clear, you can say uv pip freeze, and then requirements.txt. Yes, we can use any pip command as well with uv. So we do not have any command in uv to generate requirements.txt because we do not do it. We have dependencies in toml, but sometimes people still prefer using requirements.txt. You can still use this, hit enter, it will generate this requirements.txt file, and you can even install all the things together using this command. When I'll be uploading this project in the GitHub, you can say uv add -r, or basically uv add requirements.txt. Okay, hit enter and it will do all the things. Oh, uv add, what is saying, file but was passed in the packet. Yes. First of all, this terminal is giving me the hard time. Just say yes. So it is done. So you can even use uv add and then -r requirements.txt. The same way, the same way you do with pip. So that is the power of uv. You can use pip commands as well. You can use uv commands as well, and everything is done. Make sense? So I have just mentioned everything. So you should be good with your GitHub repo. Okay, good. Now we have the packages ready. As you can see, this is also working fine. Very good. Now what we need to do? We have chat OpenAI available. Yes, we need to pass a model, right? We want to create our model, LLM model, right? Let's create our LLM model. So we have imported this thing here. As you can see, from LangChain import chat OpenAI. What I will do, I will go to next cell and I will run this command, LLM model, or basically LLM equals chat OpenAI, because now I want to create a model. I want to use a model so that I can use that model to send my request to get the response back. And I want to use model equals, which model did we decide? I think GPT 5 Nano, right? Which was the cheapest one. And I want to set temperature as 0 because we do not want any kind of creative answers. We just need well and sorted answers. Let's initiate our LLM. Let me run this. So this will create my LLM. This is done. Okay. Now, do you know what? You can send any request to this LLM and this will work absolutely fine. Let me just show you. Let's say I want to ask any question that I will be asking from my chat GPT or whatever. I will simply say LLM dot invoke and I will say, what is AI? Tell me in one line. Simple. Let's see what is the response. We are simply testing it if it is running fine or not, because obviously we need to just first of all make sure our LLM is fine. Run this and this will give us the response. See, this is the response we got. And if we want to obviously refine it, I can say response equals this, and I can print only the content part of it. Response dot response of I think 0 dot content. Let's wait. AI message object. Oh, makes sense. So let's simply say response, and then we can simply fetch the content inside it. Okay, so a response dot content. Okay, so this is the message. AI is a science and engineering or whatever. This is the same thing that ChatGPT is doing. ChatGPT is making API calls to this model or whatever model it needs to use. And you have done the same thing. You have made the API request with your message. This is your input, and you have got the response back, and this is your response. This is your response. Wow. Yes. And how it worked? Because it used our API key. It used our tokens that we have within our account. Make sense? Response dot content. Okay. Sorted. Now we have this response dot content. That means our model is working fine. So I can just remove this cell. This was just for the testing purpose. I can delete this cell. Okay. We do not want this. Our LLM is set. our all the environment is set. So now we are good to start working with our RAG steps. So let's add a markdown. Let me just say RAG implementation with your own text data. This is the heading that we want to put for our notebook. RAG implementation with your own text data. So let's say we want to apply or basically create a RAG for our data, and that data is stored in our text. Currently, that data is not in a file, that data is not in a PDF, that data is not in a text file, nothing. It is just in a text format. We will just look at the files as well, but this is the very first step. We have the data in the textual format, like normal text things. Make sense? So let's see how we can just do it step by step. Okay. So I will say step one. Let's add another markdown. Step one will be converting basically text. So we can just create the text from anything that we have. Preparing document for your text. Okay, because we do not have any kind of document, but we have text, so we can create our document for our text. How we can just create that? You would need to import some library. I think a package called from langchain core, if I'm not wrong, dot documents, import document. So this is a function that we use called document. Okay, here you will pass your document. So I will say your text data, and text data can be anything. Let's try to get some data from the Wikipedia. Let's try to do that. Let's say AI Wikipedia. Perfect. So here we have some text. So let's try to copy some text from the Wikipedia. Let's say this is the text that you want to pass. Let's say this one. This much text is enough. Okay, just for the learning purpose. So we have copied this text. Let's say this text, for this example, this is just like text available globally. But let's say this text is something that is only available for your organization. Only you have the access. So what you will do, you will paste your text here. Let's say my text, and I will store it in the string and I will paste it here. Perfect. Perfect. Okay. So my text is here. As you can see, my text is here. So this is my text. I want to create a RAG on top of this information. Step one was preparing document for your text. Remember? And if I just pull the second step, what was the second step? Chunking, right? But is our document ready? No. So we first need to make our document ready. So what we will do, we will simply say create our document. So how we can just create a document? It's very simple. I will simply say docs equals list of document. Document is a function, and then I will say page content equals my text. Now what is this thing? This is the function that LangChain uses internally to create a document for your text. Okay, so whatever text you have provided here will be passed to this function called document, and it will create this page content, you can say a key with which we will be having this value as like value mapped to it. Make sense? Remember, I told you one more thing which is very important whenever we just build the RAG application. We always pass the metadata as well. So now along with this page content, I will create one more key. It's called metadata. Metadata is the, you can say, dictionary that we pass. Here we can just pass anything. I can say source. Source is, let's say, your organization name. It can be, let's say, ABC. Okay. Then you can say ID, a kind of source ID or basically document ID if you want to create it, because I love it. Document ID, and I want to just give it as, let's say, document 1. This is my metadata that I want to keep it. Okay, this is my metadata that I want to keep it. Make sense? Make sense? So this is my docs. Okay, and if I just print docs, what I will see, I will just see that document page. So if I just print it, this is my document converted into a list, and this list has only one object because we know that this is just one text. Makes sense. So our documents is ready. Now we need to perform step number 2 of chunking, right? So let me just say step number 2, converting or splitting the document into chunks. Remember why we need to prepare chunks? Now you know. Good. In order to prepare the chunks, we have an amazing function. Yes, by LangChain. That is why I love LangChain. There are like so many functions available to us. We do not need to do so much of boilerplate code. It's called recursive character text splitter. Wow. Let's see if I have imported that thing or I need to download this. I would say from LangChain text splitters. Yeah, we have. Import recursive text splitter. What it does, it simply splits our document into multiple chunks. Wow. But Ansh Lamba, tell me one thing. If I want to split my data, yes, and I want to create multiple chunks, do I have any kind of control over what will be the size of chunk? Yes, you have. Okay, that is a cool thing then, because we should have control over like how big our chunk should look like and how we can just do all of these things, right? So we have the chunk size variable available. Okay, so I can simply say chunks equals recursive text splitter, chunk size equals 500. Let's say I want to put only 500 characters or basically 500 text characters into one chunk. Then I will pass one more important variable. It's called overlap. Chunk overlap is 50. What is this thing? Try to understand. It is very important. This particular thing, chunk overlap, just tell me one thing. If I create, let's say, this is my document. If I create multiple chunks, let's say I created these two chunks. This chunk is created from this. This chunk is also created from this. But you know what? Sometimes when we create chunk, this information, let's say there was some information here, like at the footer of this page, which is not complete. It was split into the second chunk. But obviously, if I just use this chunk only, this will be a little bit misleading. Why? Because I do not have the complete information for this broken end, for this broken, you can say, context. So what we do, we simply pass an overlap. That means whenever I will be creating a different chunk, I will overlap. I will take the 50 characters from the previous, you can say, chunk as well, so that the flow will not be broken. This is really powerful, man. Yeah. So we have the chunks ready. Now let's see how many chunks it has created for us, because we want each chunk of 500 size. Make sense? We need each chunk of 500 size. This is my basically splitter. This is not chunks. This is splitter, basically splitter variable. Make sense? This is only the splitter. Now let's try to create the chunks on top of it. Like this is my variable that I have created, splitter.split documents, and then I will just pass docs. Now I can just see the chunks. Let me hit enter, and it has created 1, 2, 3, 4, 5. 5 chunks. That means I had the character text around 2500 or 2400. That's why it has created 5 chunks. But you know what? The best thing, it has added metadata automatically. See, metadata, which is source and document ID, and then page content. Wow. Yes. So it has distributed our text into 5 different chunks. This is amazing. This is amazing. Yes. Now we need to do the heavy lifting. Heavy lifting, like not on our end, but yeah, heavy lifting on the model end. Now we want to create the embeddings for these chunks. Okay. Yes, creating embeddings for the chunks. Let's do it. How we can just do that? How? We have the model called OpenAI. Yes. And you know what? We have a dedicated function that we can use for, you can say, your embeddings. It is called OpenAI embeddings. Okay. So that model uses that embedding model under the hood and creates embedding for your text. Let me just show you. So you will write from LangChain core import OpenAI embeddings. Perfect. So this is the function and this is the modeling. I think this is LangChain OpenAI because this is with respect to OpenAI. Yeah, OpenAI embeddings. Okay. Now I will create my basically OpenAI embedding model. Okay. I have two options, obviously. So I will say embedding model equals OpenAI embedding, that is the function name, and the model I want to pick. If I do not specify anything, it will by default pick this model, which is called text embedding 5 small, which gives me the embedding for, let's say, 1536 dimensions by default, because it is like suitable enough and it is like powerful enough to convert those things into contextual meanings. But sometimes people want more richer embeddings, more richer context. They can use a large model as well. We will be using small model. So I do not need to specify anything here, but I can specify. If I run this, it should run fine. Perfect. Makes sense? It should run fine. Like I can. Even if I, let's say, run it without any kind of, you can say this thing, it should also run fine. See, because by default, it takes that value. By default, it takes that value. But I always specify, like I always love specifying the model because it makes more sense. Like it will tell you like which model are you using, which model are you using to create the embeddings. Simple, right? So now what we need to do, we need to create the embeddings, right? Do you know, even before creating the embedding models, let me just show you how you can create anything into embedding. Let's say you want to create embedding for this embedding model dot embed query, embedding model dot embed query, I think, or you can say embed documents, whatever you want to say. Embed query. Let's say you want to convert this into embedding. What is AI? What is AI? Hit enter, and this will give you the embedding. See, wow. Do you know the size of this? 1536. This vector, this is a vector. This has converted this input into the vector. See, wow. So this way you can just convert any prompt, any input into the embedding. Make sense? But obviously we do not need to do this because we are just simply focusing on RAG, but I was just showing you how you can just convert anything into embedding. Okay, good. Now the step number 4. What is the step number 4? Storage, right? Now we need to store our embeddings into the vector store. Simple. Okay. Now if we want to store the vectors in the vector store, we first need to create an instance of vector store. Now there are so many vector stores available. For this particular section, we are using free vector stores. You do not need to use the paid ones. Okay. There are so many vector stores available. We'll be using ChromaDB. I love Chroma. Okay. You can also see the power of it right now. So what we're going to do, we will create our embeddings and we will store it. Ansh Lamba. You are creating the vector store. Yeah. To store the embeddings. Yes. But where are the embeddings? Where are the embeddings? Because we just have the chunks. We didn't create the embeddings. Yes, you are right. But what if I tell you create and store embeddings in vector store? That means LangChain will do the heavy lifting for us. That means when we will be creating any vector store, okay, whenever we will be creating any vector store, it will create the embedding for our each chunk and store it in the vector store automatically. Wow. Yes, it will do all the heavy lifting for us. That is why whenever I will be initializing the vector store, you will see that I need to pass two things. Number one, the chunks I want to insert. Number two, which embedding model I want to use. That's it. So what it will do behind the scenes, I will also show you. Don't worry at all. So first of all, let's discuss about the vector stores. I will say from LangChain core, I would say, dot vector stores, import in-memory vector store. You can also import in-memory vector store, but I want to import Chroma. Okay. ChromaDB is like one of the very good vector stores. So I want to create vector store equals Chroma dot. Now I need to initialize it, to be honest. Okay. So what I will do, I will simply say Chroma dot from documents, whatever documents I have. I will say from documents, and here I want to say documents equals to chunks. Whatever documents I have in the form of chunks, and embedding is equals to embedding model. This is the embedding model that I want to use. Let me run this. Chroma, it cannot import name Chroma. Are you serious? Chroma, I was using Chroma. Maybe like they have removed it. Let me just check the latest code. I think it is not in the core. It is maybe in the community, because these are some popular community-based vector stores. Let me just see. ChromaDB package cannot import ChromaDB Python package. Yeah, that makes sense. This error makes sense because I have not basically downloaded the package called ChromaDB. I can do that. That makes sense. So let's write uv add ChromaDB. This package makes sense. Okay, so this has downloaded the ChromaDB. Perfect. Now let's try to run this one more time, and it should work. Yeah, because I was using ChromaDB a lot. I love ChromaDB for in-memory vector stores. Perfect. I love hosted versions as well that I will just show you. So this is done. Do you know what happened behind the scenes? That is very important to know. What actually happened behind the scenes? Let me just explain you that. Because when I was learning that thing, I was also confused like what actually happened. So behind the scenes, let's draw it here. So what happened behind the scenes? If you will see VS Code, we simply passed ChromaDB. Okay, we passed chunks. Make sense? We just did these two things. Now let's say you are the user. So you provided only and only the things to ChromaDB. Let's say database. So this is your ChromaDB. Okay, this is your ChromaDB. This can be your any vector store basically, but we have used ChromaDB, so I'm using that specific name, ChromaDB. You had the chunks with you. Yes, you had the chunks with you. Let's say these chunks. Okay, these chunks plus you also had one model. Which model? Let's say you used OpenAI model, embedding model that you wanted to use from OpenAI. Embed model, or basically let's say embedding model. You had this as well. Embedding model. Okay. You had just these two things. You provided these two things to this ChromaDB. That's it. That's it. You provided these two things to the ChromaDB. Make sense? Make sense? Embedding model. You provided just these two things to this ChromaDB, and what it did, it just took this thing input, and this ChromaDB converted these chunks. Okay, converted these chunks basically not directly to ChromaDB. It appears that you provided all of these things to ChromaDB, but you provided this to LangChain. Yes, you provide this to LangChain. ChromaDB is like at the end of the picture. So you provide this to, let's say, LangChain. Do we have anything for LangChain? Any logo? Let me just check. Oh, whoa. So we provide this to LangChain. Now LangChain converted these chunks into vectors. Okay. Converted this into, let's say, vector 1.1, 3.3 something, or 4, blah blah blah. Converting these into 3 vectors. Okay. Perfect. Now these 3 vectors are now stored in this particular ChromaDB automatically. This is the entire flow. You provided chunks, embedding model, LangChain converted it into vector, loop by loop. What do I mean by loop by loop? So it is stored in ChromaDB like this. This is the entire flow. Okay, so what it would have done, it has run this command, basically this code. So it has run this code, let's say for doc in chunks, and it has performed the embedding model, and obviously it would have created an empty you can say vectors list, and let's say embedding model dot embed documents, and then doc dot page document. What is this doc dot page document? So see, this doc is the first thing in the chunk, okay, and you just need doc dot page document, not even in this list, or you can just pass a list because it's documents. So this has done this thing, okay, and you will simply say vector equals this, and then it would have appended this vectors list with this vector. This is the entire thing it has done behind the scene. This is the exactly thing it has done. Make sense? So it has run a loop over your chunks, and yes, it has used this embedding model that you have provided to create the embedding for the page content, and then it has just appended that vector store with those values, with those vectors, along with some metadata. Obviously, because you would need to store some metadata with each vector that you will see right now as well when you will be just retrieving the data. So that way it is doing that thing. Vector plus value. Vector plus value. Okay, I will just also show you the similarity search, and you will see the metadata and the document value as well, everything. But everything is mapped to that particular vector. Make sense? So this vector has everything. This vector has everything. This vector has that chunk in the mapping, so it returns that thing automatically. Wow. So let me just copy it here, and it has done behind the scenes is this thing. Perfect. So this is exactly thing it has done behind the scenes. Wow. Make sense? Make sense? Little bit. So this vector is nothing but this step. Okay. This step is nothing but this step. So this is the heavy lifting stuff. This is the magic behind it. Now you know the magic. Now you know the magic. So these are the outputs. These are the outputs. I hope now you know the magic behind it, because when you are learning it for first time, you will see like how it is like happening behind the scenes and how it is doing everything. That's how it is doing. That's how it is doing. Okay. So this is running just loop. So now what will happen? This will create each vector, and each vector will be converted into basically a map. This, when it will be stored, it will be stored with the mapping in the ChromaDB. That this is the thing that we can just take the things further. So this ChromaDB will be having all of these things. Let me just make it short. This is fine. So this ChromaDB will be having all of this information, because this will not just store this vector. No, this will store this vector and the metadata. This is very important to know. This has metadata plus page content. Make sense? Let's say this has this option, document, and then metadata equals whatever we have written. Metadata basically plus text. Metadata plus text. This is mapped to this. Each vector. Can you imagine? Each vector is mapped to it. Okay. Each vector. And I wanted to write it like this. Let's say the metadata. So this will look like this. So now when we want to store it in the ChromaDB, this will store the vector and the mapped text. Vector mapped chunk. Vector mapped chunk. The same thing that I have explained in the conceptual section. Make sense? So this will be, let's say, vector 1, and this will be mapped chunk. Simple. Let's say map chunk 1. Make sense? The same thing is here as well. Same thing is here as well. What do you want, bro? Same thing is here as well. Vector 2. And so on. Vector 2. And this is map chunk 2. Simple. That's what it does behind the scenes. That's exactly what it does. See? So whenever you are storing this vector, do not feel like what is going on. This is exactly what's going on. This is exactly what's going on. Make sense? So this is your vector. This is your vector. And this is your map chunk. This is your map chunk. So in your vector store, if you will query it now, you will see it, everything. This is the entire flow that you need to understand what it does behind the scenes. This is very, very important. I took so much of time to understand this thing. When I understood this, I was like, bro, I know what is going on. I know what is going on. It is not something like which is magical. Hey, we do not even know what's going on. We do not know how it is doing everything. We know how it is doing everything. So now if I just bring that VS code, you know how it is doing everything, right? This vector store is there. This vector store is created. That's it. Now you can perform anything that you want to perform. Let's say I want to say vector store dot similarity search. We have a function called similarity search. I will say what is AI. Make sense? And I will pass the parameter, let's say k equals to 2 or let's say 3. I just want 3 top chunks, and let me run this. You will see 3 chunks. See now what actually happened. I said what is AI. I got 3 relevant chunks based on the similarity search. Let me just continue that. So what now happened? Now this chroma db is there. Let me just copy it here. So now what happened? Now we have this chroma db. Now if I, let's say, query this is initiated. Okay, this is initiated. That means I have this particular chroma db with me. Obviously I have this chroma db. So now what I can do, let's say I am the user who want to use this thing. Okay, I want to use this. Perfect. Now what will happen? Let's say I am the user. I will simply say, bro, I want similarity search, and I ran that code that called similarity search. Let me just bring it from here, and let's say I run this code. I'm just explaining you, bro, everything in detail, but I know it like it is very, very, very useful for you. So let's say I ran this code. Okay, this is my code that I ran. Now what happened? It performed similarity search. Okay, this model performed basically this chroma db returned these 3 vectors. What is AI? So this what is AI, this what is AI, this what is AI, this is this question, this what is AI gets first converted. This will, let's say, vector store dot similarity search. Let me just put it to the next line. Perfect. Let's say I ran this thing, vector store dot similarity search. This is my question. What is AI? This will be converted into a vector using what? Using model. Okay, using model. So this is the thing. So this will be converted into a vector. Okay, and this vector will look like this. Let's say something. This vector will go to this chroma db. Okay, similarity search, and this will return me. Let me write similarity search. Similarity search. Okay. Similarity search will happen here, and once we have the similarity search, it will return me top 3 vectors, and those top 3 vectors will return me the mapped chunks. That's it. That's exactly going on here. That's exactly what is going on here. It is returning me these 3 vectors, vector 1, vector 2, vector 3, and then top 3 chunks are returned. Let's say similarity search, and these top 3 chunks, these top 3 chunks are returned. These top 3 chunks are returned. Make sense? These ones. And I can say like these are top 3 because I have specified the value of k. Top 3. Top 3 mapped chunks. Top 3 mapped chunks for the vectors. That is the complete definition. Top 3 mapped chunks. It has returned this. Make sense? Make sense? Top 3 mapped chunks for the vectors. And this information is coming back to me. This information is coming back to me. Okay. That's it. That's it. This is exactly the flow after we create our ChromaDB. But this step is important to, first of all, initialize the ChromaDB. Once it is initialized, then we can just query it using our any query. What is AI, blah, blah, blah. This will be converted into vector, then similarity search from this ChromaDB, and it will give me top 3 map chunks and it will return me the result. That's how it works. That's how it works. Make sense? Wow. Now, let's say you have got this thing. Okay. Now you will say, Anshlamba, what is the benefit of it? Benefit of it. Let me just tell you what is the benefit of it. Now you will ask the LLM again. You will say, you want to ask the LLM, and this is similarity search. Step 5, or semantic search, whatever you want to say. Semantic search. Perfect. Now let's say you want to talk to LLM. Okay. And you want to provide the context. You will simply say talk to LLM. This time you will not just say like this, LLM.invoke, and you will say what is AI. You will not like that. You will not write like this. You will say what is AI, and you will add a prompt. You can answer using the following context, and then you will pass the context. Okay, context, and this can be any variable. Let's say this is the variable output of this. Let's say I want to pass the variable. I will say context, and this is my question. Make sense? In the real world, we make it like so robust that it will be like all automated that we do with LangChain. And don't worry, in the very near future, we'll be having a complete course on LangChain as well. And if you need it, just let me know, because for AI data engineers, LangChain is a go-to tool. And that's why you are just seeing LangChain in all the modern job descriptions as well. But do let me know if you need that course. Okay. So let's say this is my context that I want to pass to the LLM. Then I will simply write context here. And we just create chains in LangChain so that everything is automated like step by step. The same way we create ETLs. It's very similar to that. So now if I invoke this, I will get a better answer because I have provided the context that I want to use. Make sense? That I want to use. Here is the answer. See? And we can also catch it in response. Okay, perfect. Print response dot content. Perfect. This context can be literally anything. Literally anything. Wow. See? Oh, here's a concise. Oh, okay, makes sense. We didn't pass the context. Wow, lol. Now it will work. Now it will work because we didn't pass the f string. So yeah, now this will give me the answer based on my context, that I have provided to this LLM. Did I upload any data to the chat GPT? No. Did I do anything, let's say, with my sensitive data? No. I simply provided the context on the fly using my RAG database. Wow, this is the power of it. Okay, makes sense. That's how you can do a lot of things using RAG database. Make sense? Very good. This was a very basic example. Now in the next example, in the next notebook, what we're gonna do, we'll be creating, you can say, a more realistic RAG application where we will be uploading a PDF file. And it can be any PDF file. We will download any random PDF file from the Google and we'll upload it in our folder, and we will then create a RAG on top of it. Wow, this will be like more robust. Okay, let's try to do that. So let me just import my documentation, and it is this one. So it is called fabric1lake.pdf. Simple. So we know that our document is here. Very good. Now what we can do, let's create a you can say RAG on top of it. Simple. Very good. Now what we're gonna do, we will simply run this thing and attach this notebook to the same virtual environment. Okay, good. And okay, API key is set, that means it is fine. Let's run this as well. Let's create the LLM using the same chatbot. Basically not chatbot, like chat OpenAI model. I love this model, GPT-5 Nano. It is cheap and it is like good model. And I will say with PDF. Perfect. So step 1, preparing or basically extracting. So here we already have the document ready. We do not need to create a document for our text. We already have a PDF. Now we want to extract the text. Extracting text from PDFs. So how we can extract text from PDFs? There are so many libraries in Python we can use, but you know what? I love LangChain. LangChain has provided some amazing classes, functions that we can use to extract text from the PDF. It is called basically document loaders. They have created this particular package available for us. It is called document loaders, and we can specify which type of document we want to load. Let me just show you what is that. And again, it is like a community class. So I will say from LangChain community dot document loaders, I want to import PyPDF loader, or basically PDF loader. PyPDF loader. Perfect. So I want to import this package, PyPDF loader. Do you know what? How many loaders do we have? Let me show you. Click here and you will see so many options. Airbyte, RCIF loader, we have AstraDB loader, we have Azure Data Lake loader, Azure Blob Storage loader. They're like BigQuery. There are so many connectors available. You can load data from anywhere. Wow. Glue, Google, whatever. LangChain is like, that's why LangChain is leading. There are so many agentic frameworks in the market, but why everyone is like using LangChain? LangChain is like amazing. So see, these are the stuff available within the document loaders .pdf. Import this PyPDF loader or so many other things. So for now we want to use PyPDF loader. Makes sense. Now we need to specify the path. PDF path, or let's say one like PDF path. Let's say PDF path is in the same folder, and then within the same folder we have folder called docs, and within that we have fabric one lake, as you can see, .pdf. Make sense? This is my path. Perfect. Now I will use this PyPDF loader. So I will simply say loader equals to PyPDF loader path. So what it will do, it will load that PDF for me. Okay. It will do what? It will load that PDF for me. Okay. Like whatever PDF I have, whatever. Okay. Then I can say docs equals loader.load. Loader.load. I also prefer writing like this if you are more familiar with this kind of syntax, like first of all specify the loader where you have in the PyPDF, and then just specify the load method. Up to you, you can use anything. So let me just create this and let's see how our docs look like. PyPDF package not found. Very good, because we didn't include PyPDF. Let me add it. UV add PyPDF. Perfect, because under the hood it will use PyPDF, obviously we know that. So let me now run it again. Perfect. So it will create docs the same way it created for our text, but this time it will create so many documents. Why? Because that PDF is really big. If I check the number of pages, I think it is a big one, man. See, 382 pages, so it is a big one, but we have everything available, and that's the real use case of RAG. Let's say you want to create a kind of assistance for our documentation. Let's say you are building a kind of chatbot for your developers, where if they have any query regarding any technology, regarding Fabric 1 like specifically, they can go and chat. Simple. It can also resolve some errors if they have. So it is a cool, you can say, real world application that you can build using RAG. Okay, so we have documents ready. Perfect. Now do you know what we need to do? What? We simply need to split this document into chunks, and let's create a chunk size of bigger. Why? Because we have, or let's say 1000 is enough. 1000 and 100 is our overlap. Let's do this. Let's create chunks. So our chunks are ready. So now let's see the size of chunks. How many chunks do we have? 652. So we have 652 chunks. That means we'll be having 652 vectors, embedding vectors for it. Make sense? Very good. Now let's create the embedding using the same model. Perfect. Now let's create the vector store for this. Perfect. So it will create another in-memory vector store for us. Error code message model does not exist. Are you sure? Are you sure? Do not have access to it. Type invalid request error. Okay. Okay. Just replace this text embedding small. I think this was the model name. Let me check. OpenAI embedding model. Yeah. So this is the one we are using. Text embedding 3 small. Oh man. Let me copy it from here. Text embedding 3 small. Okay, let's use this. Who wrote 5 there? Who? Let me replace it. Perfect. And let me just change it here as well so that it will not fail in your first notebook. Perfect. Maybe this AI corrected it. Let's try to run this one more time. Let's see if it works. Yeah, it works because that is the model. I don't know who wrote 5 there. Okay, so we have our vector store ready. Vector store means now you know everything, bro. Now you know like what is happening under the scene, under the hood. It is trying to create a vector store using your model. Make sense? Using your model. Which model? This one. You have just used this. See? You have just used this. So you now know what is happening under the hood. It has created that particular vector store for you, and it has also put the data for you. Make sense? Makes sense? I hope it makes sense. So now you do not need to do anything. You do not need to do anything. Nothing. Okay. So now if I ask you one simple question, and you should know the answer of this. Okay. If I ask you a very simple question, what will be the content? It's a kind of small quiz for you. What will be the content for this particular model? What will be the content? Not like model, for this particular vector store. What will be the content? Just do let me in the comment section right now. And yes, just do let me know in the comment section right now. So the content will be very similar. Embeddings plus metadata. Now Ansh Lamba. Yes. Ask that question. I know your question. We didn't provide any metadata. We provided metadata in case of text, but we didn't provide any kind of metadata here. I know. So how it created this metadata? See, let me just show you the chunk, like only one chunk so that you can see better. Chunks of 0 dot metadata. Let's see. So this is the metadata. I didn't create this metadata. I didn't create this. It created it for me. Oh, so if we are using any PDF, any text document, LangChain, PyPDF loader will automatically create the metadata for us when we will be creating chunks. Because if you remember, when we loaded this data into docs, this is our docs, even before applying the chunks, this was the metadata that was created by PyPDF loader. Oh, so that is the advantage of it. That is the advantage of it. Makes sense. And I think this is very, very handy. This is very handy. But Ansh Lamba, yes. What if we want to overwrite this metadata? I didn't like this metadata. I want to put my own metadata. That is a very good point. Let's say you want to add your own metadata. You would need to do that step while passing the documentations for embeddings. So let me just show you how you can just do that. So let's say this is your documents. Make sense? Good. This is your documents. Now you have this metadata, which is already created by LangChain. You didn't create this, but you didn't like it. So you will simply say documents, or I can create a markdown, creating own metadata for PDF chunks. Okay. If you do this, then you know what you need to do. You will simply say chunks metadata, or let's say chunks with metadata. So now you will run a loop. Okay. So you can just get started with any kind of empty you can say list. It's up to you because there are like so many ways to do it. So what you can do, you can simply say docs. You can run a loop, let's say like this. Let's even remove this. You will simply say for I in chunks. Oh, we don't have chunks. We have chunks here. Oh, docs, sorry, docs. Yeah, perfect. So what it will do, it will run a loop in the docs. Okay. If I say I want to change something in the docs, makes sense, because you know list have the capability to make in-place changes. You should know about it if you don't know. It has a capability to make in-place changes. So what I can do, I can simply say I.metadata, because what will be the metadata? What will be the metadata? This one that we just saw, this one. I want to overwrite it for each element. I can simply run a loop. I will say I.metadata equals a new dictionary, because I want to do this. I will simply say source, and I don't want to create a source. I will simply say, let's say, let's say source. So this is the source. I want to just keep this metadata. Let's add one more key. Let's say I want to say author, not author. I will say developer. Okay, developer. Let's say developer is Microsoft. Makes sense? So I want to keep this metadata. Do you know what? The moment I run this, now if you see you can say docs, you will see the new metadata, see? Or if I say 0.metadata, you will see this. Where is that? See? Only source and developer. This way you can overwrite your metadata, because metadata is very important for retrieval. Very, very important. So obviously you can use a default metadata as well, but you can overwrite it as well. Okay, makes sense. So we have overwritten it, and let's create new chunks. Okay. Now if we will be just looking at the metadata, we will see just this thing. Very good. So we have the metadata for these chunks. Now we will say, Ansh Lamba, why you didn't run a loop here in the chunks, and why did you run a loop in docs? Simple. Because I would be running loop in a shorter list instead of just running the loop in a bigger list. So just trying to optimize the memory. That's it. Nothing special. Now let's try to create the embeddings again. Okay. Now let's try to create the vector store. Now this time the vector store will have the metadata that we have provided. Perfect. Now let's try to test this vector store that we have newly created. I will simply say, how one lake is, or let's say, why do we need one lake? Why do we need one lake? Tell me in one line. Perfect. Let's try it. Or let's say, why do we need one lake? That's it. Simple. Now let's see how it will give us the top three. Perfect. Top three chunks. See, metadata, producer, this. Okay. And why it has created, okay, makes sense. Now you will be like, okay, that's a very good one. Why we are seeing a different metadata? Because do you know what? We already created our vector store and we added more documents into it. So we would need to rerun our thing. So let me just save everything and let me just say reload window, or basically restart the kernel. So I would need to restart it. Yeah, perfect. So just to make sure like this is restarted, let me just try to do a similarity search and it should throw the error because yeah, perfect. Vector store is not defined. Let me do it for one more time. So I will go at the top and let's try to run everything because it already stored the previous ones and I was showing you the better way to store the metadata. Perfect, but not a big deal. Okay, so now we should see our, you can say, metadata. Now you are seeing source and developer, perfect. Our own metadata that we created. And we have the page content, one lake drive for data article, whatever we are just seeing it here is just the response. That's how you can create a RAG on top of your PDF as well. Wow. Wow. Literally wow, man. Makes sense. So now I have a quick question. Okay. Now let's say you will ask this question. Every time I am coming to this LLM and I want to ask some questions regarding this. Ansh, Lamba, we just saw that if we restart the kernel, that vector store also gets vanished. Obviously, because this is an in-memory vector store. Okay, this is an in-memory vector store. So Ansh, Lamba, is there any way that we can persist our vector store so that we do not need to reinitialize our vector store every time we come? Is there any way we can create a vector store once and whenever we will be just talking to LLM, we can just reuse the vector store that we have created? The answer is yes, you can do that. And how? It's very, very easy. So obviously, this is a very good question, by the way, because see, you would need to persist the data in order to reuse your vector store. That's why we are creating a vector store, right? So we can do it using something called as persist function. Using what? Persist function. That's it. Yeah, that's it. So now what happens? Let's say you want to persist your data locally in your folder. I can even show you. Let's say you want to create a folder called, let's create a folder here and let's call it as vector store. Okay. Or let's say DB. This is our DB. Or let's give it a new name. Let's say store. Or let's say vector. Vector is a cool name. Okay, let's say vector. This is our vector store. Do you know what? I can store everything in this particular folder. What? Yes. Let me just show you. So first of all, let me just restart everything so that I can just show you. And currently see this folder is empty. Nothing inside it. Nothing. But let me just rerun everything because we need to perform all of these steps. Yes. Okay. Or even let's create a new notebook so that you will have a clear understanding that this is a persisted database. That will be a better approach. Let's do that. Just for your notes, see how much efforts I'm putting for you. So I will say rag local persist. Simple. Let's run this. Select kernel. Kernel is this one and perfect. Perfect. So we will use the same, you can say, PDF that we were using before. Perfect. And this is also done. This is also done. Chunks are created. We can check the metadata. Perfect. Now is the thing. We have created our embeddings. Perfect. Now when we'll be creating our vector store, we will pass one more parameter and we'll say in local vector store. I will pass one more parameter. It's called persist directory. And I need to just pass the path of it. And the path is very simple. It's the same directory. And within this directory, I have something called as vector. Okay. Simple. Obviously, like I have this folder vector and I just want to persist everything within that. Simple. Okay, perfect. Let's try to run this and you will see the magic. Let's see the magic. Okay, now if I open this particular folder, boom, this is my vector database. It has persisted everything. Wow, literally wow. Yes. Now if I query this data, obviously I know I will get 3 relevant chunks. Now let's do one thing. Let's restart the kernel. Okay, kernel is restarted. Good. Do you know what? I can now perform the similarity search on this vector store directly without even performing all of these things. Why? Because I do not need to do that. Because I already have this vector store. This is persisted. This is not gone. Now I can just query this. Okay. Makes sense. But how we can just create that particular connection? How? Let me just show you. For that, we will use a simple thing. It's called chroma connection. Okay. So now you know that terminal is like stopped and I can even show you. If I just search anything, it will throw the error. See, this is not created. So now I will create the connection. Semantic search, we know that talk to LLM, blah, blah, blah. Now we will simply say, let's remove this, talk to LLM, this one. And now let's rename it test, or let's say reuse the vector database. Perfect. Now we're gonna reuse a vector database. I will simply say vector store, and let's rename it just for your confusion. Persist equals to chroma, and then I will say the location, like persisted directory. Persist directory, it's called vector. Simple. That's it. And then embedding model. Now, why do I need to pass the embedding model? Because remember, whatever query we pass to the model will get converted into the vector, and it uses the same embedding model, right? So that's why we are passing the embedding model. That makes sense. So obviously we would need to run only the necessary cells. The one cell is this one that we need to run. Without this code, I can comment it out. I will simply import chroma. That's it. I can now make it back. I'm not running this in front of you. See, I'm not running anything. And I need to run one more thing, which is called embedding model. So I would need embedding model. That is it. I do not need anything else. I do not need chunks. I do not need anything because I am using this same vector DB. Let's see if it works. Okay. Now let's try to query this thing. Let's ask the same question. Vector store persist. Let's see. Boom. This is your efficient way to persist your RAG. Wow. So that way you can persist your RAG. Very good. This is awesome, man. If you are just getting this, you can store this locally. See, it will create a SQLite database under the hood, and it will create or store all the files under this folder, and you do not need to manage anything. Nothing. Wow. That's how you can just reuse your vector store again and again and again. Now, one last thing that we need to discuss in RAG. Is there any way that we can store more and more data? Because Ansh, in the modern applications, let's say we just created this RAG application for one lake. Now let's say we want to add more functionality, we want to add more tools, we want to add, let's say, Databricks, we want to add Snowflake, or even forget about those tools. Let's say we want to add more features of Fabric. Let's say we want to add Fabric administration as well. Let's try to get the PDF for that. Let's say Fabric administration documentation, right? Because we want to make our chatbot robust enough to handle all the requests. So this is the documentation for administrators, right? Let's download this. So it has downloaded this PDF called fabricadmin.pdf. Perfect. Now you will say, Ansh Lamba, let's say I want to add this PDF as well in my RAG. How we can just do that? Because you just showed us the example where we create only one RAG per documentation. Is there any way we can add more and more things into the existing RAG? Like the same way we do with the normal databases? Yes. Really? Yes. Let me show you how. So you can create a new notebook. Let's say 4.0 and then RAG add. Basically add documents. So now what you need to do in this, obviously you will perform all of those things, but you do not need to create a new vector, right? You do not need to create a new vector. Yeah, you do not need to create new vector. Basically new vector stores. Okay. Because you just want to add more things, right? Just add. But you do not want to do anything. Yes. So what you can do, you can create your chunks, just chunks, and create the embedding out of it, obviously. And then you need to simply, basically embedding will be done by the model, and you simply need to say, I want to add these chunks. Wow, let's do it. So let's actually clone the previous notebook just to save some time. Okay. And let's say rename 4.0 RAG add documents. Perfect. Now if I run this, select kernel, this one. Perfect. So this will set the API key. Is it done or it is running? Okay, it is running. Okay, let's wait. So I hope you are getting my point. I hope. Make sense? Okay. So now let's wait for it to complete this, or let's open a new one. Why it is taking so much of time? Let's rename it. Add doc, let's say, because it can happen because we deleted the previous one. Sometimes it happens. So import OS. No. Oh man, let me just refresh everything. Reload window. Perfect. Now let's try to run this. Sometimes it creates a mess, but it's fine. We are here to solve. See, it's solved. So now this is done. Now we will simply create OpenAI. Yes, we will create LLM, extracting text. Now we want to create vector store for this particular documentation, and it is called Fabric Admin. Let me upload it here. Perfect. Now the best thing about this is that we do not need to reprocess anything which is already there. No, we just need to process a new one. So I'll simply say Fabric Admin, and let's create the documents out of it. Okay, perfect. And now let's change the metadata as well. And I will simply say source is Fabric Admin, so that if we want to apply some filters while fetching, we can do that. Perfect. And now let's create the chunks. And we can see the metadata. Okay, now we do not even need the embedding model, but let's still run it. Now this is the thing that you need to change. Now we want to say store embeddings in local, or let's say in the existing local vector store. So that means you do not need to create a new vector store. You need to simply create the instance of the already existing vector store, and you need to add the documents there. How you can just do that? Do that. You will simply say chroma. Okay. Chroma, and then persist directory is equals to this. And you can even pass the embedding model, like let's say this, because it will use embedding model to translate it. Even if you do not specify this, it is smart enough to fetch the details of like which embedding model you used earlier. So let's try to do this. Vector store, chroma, and this, right? Let's run this. So this vector store is created. Now let's add our embedding within this vector store. I will simply say vector store dot add documents. This is the new function, add documents. Now we do not need to just create a new vector store using this new chunks. No. We will simply say vector store dot add documents. Make sense? So let's do this. Now do you know what will happen? This vector folder will have more data. Really? Yes. This vector store will be having more data. See, all these documents are inserted. Now let's test it. Let's try to ask a question regarding administration. Fabric admin is the manager. Let's ask this question. What is Microsoft Fabric admin? Let's try to ask this question. Let's try to ask this question. Let's try to do this. Perfect. Now I got the chunks. You will say, Ansh Lamba, what is the guarantee that we are getting these chunks from the new document? Bro, just look at the metadata. What is the source? fabricadmin.pdf. Wow. So I got my data from this new PDF. Wow. Literally wow. So that's how you can just persist the RAG information locally. You can use that RAG database again and again. You can add more and more documents. You can change the metadata. You can do so much of things. You have full control. But how do you have full control? Because now you understood everything that we have discussed. Here. Remember? Because now you have the clear picture what is going on. But when you do not see all of these behind the scenes actions, you cannot understand how to do the things. But once you understand these things, all of these things, you understand the context better, you understand the concepts better, you develop the things better. This is the power when you understand or basically learn from the right mentors. Okay, so choose everything, like obviously. Okay, perfect. So now at the end, I also want to show you one last thing that I just promised in the beginning of the video. So even if you do not want to perform any kind of paid LLM calls, you have one option available. What is that option available? Like, what is that option? Let me just tell you. So let's say you want to use Docker, and you have your Docker with you, and you want to use Docker model runner to build and run the LLM calls. You can do that. Let me just show you. So let's create a new notebook, and let's say here, let's create a new notebook, and let's call it as, and don't worry, I will provide all of these notebooks, code snippets, live illustration, everything in the GitHub repo. You can go and just learn, just enjoy. Everything is available with this free YouTube video, and that's it. Docker model runner .ipynb. Now you can run the models locally as well. Really? Yes, you can do that. Let's try to do it. Okay, it will be fun. So for that, you need to have Docker installed, and I already showed you from where you can install Docker. I have already mentioned about the video that I have created for Docker installation. Like, it is a full course. You can learn Docker as well if you want to, because Docker is one of the most in-demand skills right now. But just for the sake of this video, you can watch only that particular chapter, which is 15 minutes long and which tells about Docker installation. Simple. Okay, perfect. So here what you need to do, open your Docker, and let me just turn on my Docker as well. So, and in that particular Docker, I will just tell you how you can just enable so many things which need to be turned on. So I have clicked on my Docker application. It will take just a few seconds to turn on. Oh yeah, it's here. So this is my Docker application. Okay. So it is just starting my Docker engine. Let's wait for a few seconds. So my Docker is up and running. So now what you need to do, you simply need to go to settings. Okay. You simply need to go to settings, and then you should go to AI, and you should enable host side TCP support, because this is very important. This enables you to make API calls to the LLM, because all the LLMs that you will be installing will be running locally on your machine, because these are open source models. So that if you need to just, let's say, make some API calls, so then you have to use this particular port which is called 12434. So you have to enable it, otherwise it will not work. That's it. Because right now, if you just go back to your tab called models on the left hand side, you should see everything here. So I have downloaded some models. In your case, it will be empty. Just go to Docker Hub, and here you will see all these open source models that you can use. Yes, there are so many models. If you just keep on scrolling, you will see all the models are listed here. Ministral, DeepSeek, Quen models are like very, very popular nowadays. That's why I also pulled one Quen model. But you should not even like pull it directly. You should always click here and just see what are the options available, because some models are really, really huge, 7 gigs, 14 gigs. Some are small, let's say 1 gig. So I downloaded some models, let's say these two. This is like very, very basic one, 360 megabytes. This is a good one, AI Quen 3.06 F16. So you can just also do that. How? Simply click on this particular thing and just simply say download. Not this one, this is really big, 640 gigs. Okay. And then you can say Quen 3, let's say. These are fine. Quen 3 BUD. If you want to use it, you can simply say pull, and it will show that model in your this space. Now, if you just want to interact with it before even, let's say, integrating it with your code, click on any model. Okay. This will open this particular model in your machine. Make sense? I can just simply chat. Hey, what is AI? Tell me in one line. Why one line? I'm not paying for any API, so just tell me in detail. Hit enter. So this will give me the response. Why? Because this model, it's called Quen 3, 0.6 billion parameters and -F16 is running on my machine. It is free of cost. I'm not paying for any kind of API. So I have got the response back. So this is the kind of chatbot that Docker has provided us on top of this model. If we want to integrate this model in our code, we can do that. It's very easy. It's very, very, very easy. But there are some things that you need to make sure. Let me just open the documentation for that, for Docker model runner. And especially if we are just using it with LangChain, because it is very important to know about all of these things. Run AI models locally. This is just a quick tip for you. Where are the, where is documentation? Yeah, here. Perfect. So if I go to DMR REST API, I will see that I can use this particular URL to make the API calls. Okay, to make the API calls, but it is not very simple, because in LangChain we do not have a direct connection with DMR, because this DMR is something new. I hope it will be like very soon available in LangChain or any particular framework. But the best thing is Docker model runner uses OpenAI endpoints. What does it mean? It means, let's say if I am using OpenAI endpoints, if I just show you here, if let's say I'm using this chat OpenAI, right? I can use the same syntax to initiate my any DMR model. Wow. Wow. Literally wow. So I do not need to make any changes to my code. The only expectation is I should only use the OpenAI syntax, and that's it with respect to LangChain, because it is, you can say, available for us to use any OpenAI syntax, because this uses all the OpenAI features for its model, all the models. Now you say, Ansh, Lamba, there are so many models, right? Let's say we download this model. Is there any way we can download more models? Yes, you can download more models from the Hugging Face as well. Docker model runner supports that as well. I'm not a big fan of using Hugging. Okay, let me correct my statement. I am a big fan of using Hugging Face. Very good. But when you need to integrate Hugging Face with Docker, I would say you should better stick with DMR models only, because they are more compatible when you need to run it. But yes, I'm a very big fan of Hugging Face. To be honest, like jokes apart, I'm a big fan of Hugging Face because it has like provided all the open source models to us. Okay, but today we are talking about Docker model runner. So how we can just do that? The initial steps will be very, very simple. And for that, we do not even need any kind of API key. So I will not import any kind of API key. So I will simply say from LangChain OpenAI, import chat OpenAI. That's it. Now just follow the steps very carefully. Okay. From chat OpenAI. Perfect. Now I have the chat OpenAI. I want to initialize an LLM and I will call it as LLM local. Perfect. And I want to use this model, which is this one. And just make sure that you have Docker installed. I'm again repeating again and again. And just make sure the model is running. Perfect. Let's try to run this. It will throw me the error. What? Why didn't it throw me the error? Because let's check. Because I was expecting it to throw me the error. Maybe it will throw the error here. Invoke, let's say, what is AI? Okay. Let's see. Perfect. Very good. I was expecting this error. It will say, bro, this model doesn't exist. That's so true because this is not an OpenAI model. This is the open source model that is running on my machine. But Ansh Lamba, you said that we can use the same syntax. Yes. You just need to add one more thing. So currently, whatever request you are sending using this particular connector, you are sending to the OpenAI servers. Let me just explain. All these requests are going to the OpenAI servers. Okay, let's say this is you and you are using this code. You are using, let's say, this code. So all of these requests are going actually to the OpenAI server. Okay. All of these requests are going to OpenAI server. Okay, makes sense. So how it will return me the response? Because it is going to this particular server. Okay, makes sense. So request is going to this server, which is not good because it doesn't have this model. Because we can only send the request to these, you can say, OpenAI models if we are using any OpenAI model. Any OpenAI model. Make sense? We cannot make the request to these models using any kind of, you can say, your local models or the models that it doesn't have access to. So that means we need to correct something. Yes. So here we can deroute this particular request to our local server. How? I will use my local server here. This is my local server. Okay, perfect. I will deroute this request from here to here. Make sense? But how? For that, I would need to use one more parameter and it's called base URL. Okay. Because by default, all the requests are going to openai.com. Now I will say base URL equals the URL that is provided in the documentation, which is called this one. Internal. And I think there is this one that we can use. Chat completion. Create completion. Okay. List chat completions. I think this one. Available OpenAI endpoints. Okay. Yeah, perfect. This one. List chat completions. I think this one. This one or this one. Let's try this one first. If it fails, we can use the other one as well. Okay, engines, CPP, V and chat and done. So if I overwrite my code with this one, what does it mean? And I need to use that one as well. The base URL, this one. Perfect. Perfect. So I just want to use this thing and I can remove completions because I do not need this thing. So when I run this, message invalid ID, invalid request. Okay. Okay. Invalid syntax because this is missing comma. Okay. Now let me just run this. Give me the response, please. Let's hope for the best. Will we get the response? Boom! Yes, we got the response. We got the response. Now what happened? What happened? Now what happened? Let me just make it more clean. Response equals and print response dot content. Perfect. Now what actually happened when I wrote down this code, this one, we change the base URL because here the base URL is openai.com or let's say HTTPS. This is the base URL. Make sense? Now we change this base URL to the local host. We provide that base URL that it provided us, HTTPS, and then local host, and then the port is 12434 blah blah blah. But this is the thing. We derouted this thing, but we use the same syntax. Why? Because Docker model runner uses the same syntax under the hood. That's it. That is it. That is the power of Docker model runner that people are using nowadays. They are leveraging open source models and they can run literally anything. Literally anything. Makes sense? And I can say Docker model runner. Was it good? I love it. I literally love it. Let's keep it a little bit small. Perfect. So that's how you can run the models for free. Was it good? I love this feature, by the way. I literally love it. Docker model runner, because I can run anything for free. Obviously the models are not very good, but if you are doing quick prototyping, if you are just trying to build something just for your own sake, you can just use these models and this will not cost you anything. So this is another way of doing it. In case of LLM generation, it is good. But in case of, you can say, converting your text into embeddings, you need to find the right model for your use case. You need to find a good embedding model to turn your embeddings. Remember, we need two types of models. One is generative models, which will generate the text, which we have already done. You would need one more model to embed your data. Make sense? I hope it makes sense. So that's how you can work with APIs and without APIs to build your RAG applications. Makes sense? I hope you learned so much of things in this particular course, in this particular, you can say, masterclass. And don't worry at all, I will make everything available within my GitHub repo. And I can quickly add my git ignore because I don't want to include any kind of vector. I do not need to include vector. Perfect. Okay, so vector is grayed out because this is nothing but just the RAG. I can include docs because you will need these documentations. Okay, I do not need any kind of environment, virtual environment. I think rest of the stuffs are good. You can just keep it. And I can update my requirements.txt in case you want to use it. So I can simply add uv pip freeze. Oops, uv pip freeze and then requirements.txt. Perfect. Perfect. So let me update it as well. So this is also updated. You can also use it to install all the dependencies. By the way, all the dependencies are here in Toml as well. I will recommend you to just use this Toml for downloading everything. So this was all about this RAG masterclass. Now I hope that you have a very clear understanding about how RAG works. Why do we need RAG? How we can just tweak so much of things in the RAG, metadata, persistence, adding, searching, all those things. And you know the underlying infrastructure and architecture as well, like how these things are done, how these things are actually doing the stuff. This is the backbone of this video. This is the backbone of this masterclass. Like you can just go to any website and you can just copy and paste the code and your code will work, obviously, but you need to understand what's going on. This is going on. This is going on. Make sense? So don't worry, I will just provide all these notes as well in my GitHub repo. So yes, this was all about this masterclass, and I hope you enjoyed a lot. If you enjoyed, please hit that subscribe button, because I'm literally putting my heart into these videos. And if you want any specific topic, just do let me know in the comment section regarding AI data engineering, because this channel is dedicated to you, dedicated to your growth, so that you can learn and grow. Simple. Happy learning, and see you very soon. Bye bye.